conference on water with its overall theme as Water Security for Sustainable Development with Equity. We have our first technical session today on water security and climate adaptation in rural India. So I now request Mr. Rajiv Ehel, Director, Natural Resources Management and Agroecology, GIS India, to please come up on the stage. Now I request Mr. Rajiv to please welcome our main speakers and chair and co-chair. I request Mrs. Elizabeth to please come up on the stage. Can we have a huge round of applause for Mrs. Elizabeth, Deputy Head, Development Corporation, German Embassy. Now may I please request Sri Nagarendra Nath Sinha, Secretary, Ministry of Rural Development, to please come up on the stage. Can we have a huge round of applause? Now I request our Chair, Shri M. Gopalakrishna, Ex-Secretary General, International Commission on Irrigation and Drainage, to please come up on the stage. Now I request our co-chair, Shri B.P. Yadav, Scientist and Head, Hydrology Division, India Meteorological Department, to please come up on the stage. Thank you everyone for being a part of this session. We'll now begin with the session to welcome, and I will invite Mrs. Ella Visit to please say a few words and an opening remarks for the audience.
Thank you so much. Honorable Secretary, Chair, Co-Chair, ladies and gentlemen, friends. On behalf of the German government and the German embassy, I would really like to welcome you to this technical session. We feel extremely honored that yesterday, the Honorable President of India has highlighted, amongst a few others, the Indo-German cooperation in the field of water in her inaugural speech for this event. This really showcases the depth of our friendship, but also the significance of our cooperation. The Indo-German cooperation focuses on three key areas: energy, sustainable urban development, and environmental and resource protection. The most recent and politically very relevant joint declaration is the Partnership for Green and Sustainable Development, which was signed by Federal Chancellor Scholz and the Indian Prime Minister Modi in May 2022. Under this, we have also agreed on a lighthouse initiative on agroecology. With a thematic cluster of bilateral projects focusing on natural resource management and agroecological transformation, the topic of this session, namely water security and climate adaptation, becomes increasingly important. In that sense, I'm very happy and proud of our cooperation with the Ministry of Rural Development, MORD, and the Ministry of Jal Shakti, MOJS, within the Security and Climate Adaptation in Rural India, WASCA, which entered its second phase in April this year. It has been rated by an independent third-party evaluation as very successful. And I've just been speaking to the colleague who has come in office just a month ago for WASCA. One of the reasons is actually because we have such great partners that we're working with. We can only do so much with our cooperation when we have two partners that are very committed. So thanks for that. I recognize, therefore, the presence of Secretary MORD, Mr. Nagendra Nath Sinha, and knowing of his vast experience and the leadership by his ministry in taking forward the agenda for water security and climate adaptation. I look forward to hearing his vision and approach for taking this agenda forward in very trying times to the Indian and global community. Another key water-related project, which I would really like to mention, is our support to the Ganga rejuvenation, which is implemented in conjunction with National Mission for Clean Ganga, and the development and implementation support to the India-EU Water Partnership. I recognize the chair and co-chairs in the eminence of their experience bring to today's meeting of the minds for impactful actions. That said, on behalf of the German government, I'm looking forward to a very fruitful discussion. I'm very sorry I can't stay for the panel discussion myself, but I'm really, really thinking that this will be a good session. I hope we can continue our cooperation as it is. And many thanks again for Mr. Sinha. I've just learned that it's his last month in office in this function. So thank you so much for extremely good cooperation. Thank you.
Thank you so much for your kind words, ma'am. Now I request Mr. Shri Nagrendra Nath Sinha for the keynote address.
Chair, co-chair of this session on water security and climate adaptation and distinguished guests, panelists. I'm grateful to the organization and in particular GIZ and German embassy for arranging and organizing a discussion on this theme and allowing me an opportunity of addressing on this important issue. Today I was looking at the newspaper headlines and we were quite surprised to see that out of about 270 odd days of this year, about 240 days were marked with extreme climate events. 1.8 million hectares of water land was affected. More than 4 lakh houses were destroyed. More than 70,000 cattle perished. So the impact of the climate change is obvious and it's going to intensify as we go forward. We know, and all of us know, that the entire global world, entire globe and all the countries, they are not sticking to their own commitment for emission, and that's going to have an impact on how much temperature rise are we going to contend with. India's 60% of all farmlands and 40% of all forested areas are vulnerable. We are one of the most affected countries by climate change, and if we go by Global Climate Risk Index, we stand at 7th place in this regard. We have a large and vast geography and typified by different kind of agroclimatic situations, and many of our communities in the coast, in the islands are going to be deeply affected by it. This climate change are going to impact various natural resources such as water, agriculture, coastal, forest, biodiversity, livelihoods, etc. Water security is one of the most important things that we did to address uh, while looking at and worrying about what kind of climate and what kind of livelihood situation we are going to continue with. It's going to impact all our situations and all facets of our life, and the audience here does not need to be reminded by reminded of the multifarious impact that it's going to have. That is why water security and climate change are cross-cutting issues of different global agreements such as Sustainable Development Goals, uh, Paris Agreement on Climate Change, etc. The water will play as important role in the area of adaptation, what energy will play to mitigation. And all of us are aware that uh, there are only three ways in which we can cope with the climate change. One is the tolerance, or uh, second is the adaptation, and third is mitigation. So mitigation, energy, adaptation, water. So we have to address this issue of how do we go ahead with ensuring water security. Our composite water management index was brought out by Niti Aayog, and it assessed that about 600 million people, or 60 crore people are in the country, are suffering from an acute shortage of water. If we take the global data, then India, with about 2.4% of the land mass, has about 17% of the population and 4% of the world water. And if you see in terms of the water scarcity assessment, we are in the water stress category. Any number beyond per capita availability of about 1700 cubic meter puts you into the water stressed category. So you are already water stressed in the water stressed category, and as our population increases to about 160 crores by 2050 or so, our water situation is going to be more and more dire. As climate change effects spread and transmit, the water cycles are going to be disturbed, and all of us are aware. There are while monsoon rainfalls were evenly spread, now they are not evenly spread. You have huge rainfall precipitation in a day, and thereafter prolonged period of uh, rain shortage. So the rainy period is also, it seems to be shifting. In October, we never used to see rains. Now October was one of the wettest months. So lot of changes are happening, and we need to uh, do take various measures. The water security related concerns are addressed to the uh, largest possible extent. I come to this issue from another perspective. There was this issue of land degradation and desertification. And as per the land desertification and degradation atlas of India, about 30% of the land, about 97 million hectares of land is already degraded. And in some state, this exceeds even 50% of the total land mass. This is a huge land mass, and until unless we do something about it, uh, the situation is going to be extremely difficult. In 2019, the GOI raised its land restoration target from 21 million hectares to about 26 million hectares by 2030. This was the commitment given by the Honorable Prime Minister in the UN conference on combating desertification, COP14. So this is a target that is before you. I did a very simple calculation taking the issue of NRM taking care of about 60% of the expenditure, our current levels of expenditure, and came to the conclusion that while the target given for the addressing the issue of land degradation was only about 25 million hectares. If we combine resources of NREGS, the PMKSY in its different avatars, public contribution, we can address this issue of addressing the degradation of land in about 5 to 7 years of time. It doesn't need more than that. So, and obviously Mahatma Gandhi NREGS is going to play a huge role into it. Our guidelines prescribe that you can take up every sort of activity that addresses these aspects. For example, ridge area treatment, drainage line treatments, soil and moisture conservation, rainwater harvesting, nursery raising, afforestation, horticulture, pasture development. So all these activities are permissible in the guidelines of Mahatma Gandhi NREGS. The level of expenditure you are aware of. If I talk of the level of expenditures which has been seen in recent past, uh, in year 2020, financial year 2021, our expenditure was about 1,11,000 crores. Last year, in the last financial year, this was about 98,000 crores. So in terms of US dollars, it would be something like 11, in fact, more than that, it's about 12 billion dollars is the level of expenditure. And I guess even if it varies by, say, $2 billion here or there, $10 billion is the level of expenditure on this. WDC, Watershed Development Component, PMKSY, has an expenditure of projected an expenditure of 8,134 crores for about 4 to 5 years. You have the Atal Bhujal Yojana, you have the CSR component, etc. So taken together in the public kitty, there is a large volume of funds available, and the the what NREGS has done along with the NRSC is now to develop plans for identifying the NRM activities that will address these aspects. So for about 2,60,000 gram panchayats, almost 95% of the gram panchayats, we have the list of activities which will take care of this. Now, we have been emphasizing with all the state governments and all the ministries that this is not a plan for the NREGS, this is a plan for the nation. This is a plan for everyone to pool together their resources, because what we need to do is inventorize in form of the plans that have been prepared. The priorities are clear because we'll come from reach to valley. Now, everyone needs to pick up what activities can suit their schematic guidelines, their pockets, and taken together, we all can address the issue of the land desertification, degradation, water security in about 5 to 7 years' time. So from this podium, I call upon everyone to pool their resources to address this issue of water security and climate adaptation through these efforts. I would like to mention 3, 4 more things in this regard, and then I would come to the support that the German cooperation has provided us. One area is the major commitment given by the Honorable Prime Minister in terms of developing 75 uh, Amrit Sarovars in every district. So taken together, such ponds throughout the country, but it has received tremendous response, and I'm very proud to tell and also applaud the effort of all our colleagues from across the country, that about 90,000 sites have been selected. About the work has started in over 50,000 ponds, despite there being a very short window of time of about 4 months or so. And about 25,000 ponds, the work has been completed. And this time, we plan to construct another 75,000 ponds or Amrit Sarovars, so that taken together in the year leading up, in the remaining part of the year leading up to 15th August 2023, we will have about 1 lakh ponds throughout the country, Amrit Sarovars throughout the country. I also call upon our colleagues to ensure that the issue of renovating all the silted tanks is also taken up on a very large scale. You see, when a pond gets silted up, it's not able to recharge. It is a big source of methane emission. And obviously, because of lack of water storage capacity, you can use only to the limited extent of its capability. So from all consideration, the issue of renovation of silted tanks, existing tanks, is an important agenda. And if all of us are pull together our resources, including the 15th Finance Commission grants, the CSR, the public efforts, we can, in a very short period of time, take up renovation of all the silted tanks of capacities which the community can themselves handle. It's not a issue which is insurmountable. It should not take 10 years of effort to do that. In a year or two, we can handle this. I'm pretty convinced about it, and I call upon everyone to pull in this task. One tool that the Ministry of Rural Development and Panchayati Raj taken together have addressed is a tool called Jal Doot. And Jal Doot is based on a very simple idea. The idea is that the groundwater table varies across the rain cycle. Uh, After the rains, the soil is saturated, and therefore the groundwater table rises. And as we move towards the period just before the monsoon, it has been drawn to the maximum possible extent. So we are measuring the water table in shallow water wells uh, after the monsoon, and then once just before the monsoon. And the difference between the two is the impact that has been there because of human related activities or nature related events. And the goal should be to minimize the difference between the water level after the monsoon to the one just before the monsoon. So this becomes a starting point of discussion of the entire village community. And in fact, we have mentioned this as in our guidelines for both the GPDP as well as NREGS annual planning cycle. So this should be presented to the community, and it will be measured in all the 650,000 villages in about 2 to 3 wells each. And this would enhance the understanding of the community of the groundwater cycle as we progress across the rain cycle, traverse the year, and also trigger discussions on the rains and the groundwater table and water budgeting, etc. I also would like to discuss that these issues we cannot address in isolation. NREGS cannot handle it. All programs working alone cannot handle it. In fact, we have to bring the third component of the natural farming also at this stage. Uh, Natural farming, if people who have followed what has happened in Andhra Pradesh will realize that it has enabled green cover throughout the year, even in places which receive very scanty rainfall, places like Anantapur in Andhra Pradesh, which is known to be a dry area, and through the natural farming work, it has been able to maintain green covers through a variety of measures, uh, which, which you can learn by going to the sites of Andhra Pradesh Rayatu Sadhikar Sanstha, which the German government itself has assisted through their lighthouse project on agroecology. So we should sensitize people about the groundwater and the surface water and the entire issue of water security. We should enable them to take up activities that address the issue of water cycle and water availability and water security. And we should couple this with efforts of different choice of farming practices, which allow them to use to the maximum possible extent and get maximum productivity out of the existing stock of water resources. That should be our three-pronged approach, and uh, we applaud the effort of the and the support that we have got from the German government through their VASCA project, and they have brought out different guidelines which should be available on their sites, and if necessary, we'll also place those documents onto our own website. Our teams will work with the GIZ in this regard. Uh, so, ladies and gentlemen, I call upon all of you, and through this podium, everyone who is listening to it and everyone who will get to learn about it, the issue of taking these things seriously and mounting a collective effort towards addressing these issues with the available armory of the schemes and resources that we have with us. And uh, I can assure you that if we put our heads together, we can address these issues to a very reasonable and large extent in a reasonable period of time. Thank you very much.
Thank you so much, sir, for your kind words. I now request Shri M. Gopalakrishna, ex-Secretary General, International Commission on Irrigation and Drainage. He has over 5 decades and a half experience in dam engineering and had handled many aspects of hydropower, water resource planning, development, and management. He had served CWG for more than 36 years in different capacities. I now request him to please say a few words. Thank you.
Honored colleagues in the dais, of the dais. It is my privilege to stand before you to say a few words on this very important topic before us. As you know, right in the inaugural session, it was well brought out as to the compulsions that we face in the light of global climate change. Quite a few issues came up, and this particular session, together with our collaboration with GTZ, is going to bring out valuable information as to the direction in which we can proceed. You know, the global climate change is now quite acknowledged. There was a hesitation initially, even in advanced nations, But the way things are standing or frightening as days emerge, years emerge with all this pollution that is of a very, very severe order, everybody is now trying to acknowledge that we have to take on board the climate change and also see how the adaptation strategies could proceed in different disciplines, be it in energy or agriculture. Of all the things, water has to be brought to the fore in the country's agenda because water security is an important thing to achieve anything and everything. And when it comes to this, we have to also see solutions of a wide ranging nature. It could be large or it could be small. It could be concentrated or it could be widespread. It is a global challenge, and local actions do matter, but any one of the things alone cannot counter the impact of the climate change and the risks that we are going to face in this world. So given that, my few words, I would say that when it comes to water security, we have to look for solutions, both big as well as small. Small is beautiful, big is bountiful. Storage is an important aspect, and right from the inaugural session, it was pointed out that we are yet to create sufficient storage to ensure water security for all our population, be it in drinking or in agriculture or in other associated sectors. When it comes to energy also, now we have to see that coal has to be avoided. And when we are trying to look for solar or wind energy, the grid security is possible only with hydro and other types of energy generation. And that brings us to the fore. When it comes to macro solution, we have to see, given the entire country is full of scarcity or water richness. Recently, we saw a flood in Pakistan, which is essentially due to human interventions in the globe and the resultant nature of the occurrence of rainfall. And it is not necessarily Pakistan that should concern itself with this type of changes. It could as well be in our own country had we transposed the type of storm that has virtually caused so much damage to our neighboring country. So this brings us to the fore some of the scientific studies that we used to do, be it in hydrology or hydrometeorology. How do we take on board the climate change factors meaningfully and then also work on our future actions? I find quite a few papers apart from GAS it also scheduled for this session. We are going to learn quite a bit, and with that few words, I just am looking forward to a very interesting session with the participation of all of you. Thank you.
Thank you so much, sir. I now request Mr. Shri B.P. Yadav, Scientist and Head Hydrology Division and IMG. He is a distinguished scientist having more than 30 years of experience in various domains related to the field of operational weather forecasting, hydrological services, and public weather services.
Thank you, and good morning to all of you. Respected dignitaries on the dais and fellow delegates, participants. First of all, I thank the organizers for arranging such a wonderful India Water Week on a theme which is so related to all of us, impact of climate change on water security. as the chairman and the chief guest of the today has already said that climate change is impacting all of us, and the impacts are now visible in the form of its consequences. Earlier, there was of course a doubt whether climate change is happening or not happening, but now it has been proven through observations that yes, climate change is a reality. The impacts are visible in the form of increase in the temperature, increase in the precipitation, change in the pattern of the precipitation, the heat waves, the melting of the glaciers, rising of the sea level, and all so many things. And the impact has become so widespread now and is becoming increasingly profound day by day. And it has gone now beyond financial and economic aspects. We have to look into it on day-to-day basis in our day-to-day life and our activities. For water security, of course, climate change is a great challenge to water security of our country. Not only country, it's global in nature now. And any change in the precipitation pattern will definitely affect our water availability to different regions of the country. We all know that there is a huge linkage now between the extreme events which we call in meteorological terms El Nino and monsoon patterns. Earlier, this monsoon is a non-factor which gives us precipitation or rainfall during June to September. Now the things are changing, that the rainfall which is being received by our country is now decreasing because of the climate change. It has been proved that the climate change is resulting in a decrease in the rainfall amount, increase in the temperature, the change in the season of the rainfall. Earlier, June to September is a monsoon season, but now, through our observations, India Meteorology Department had demonstrated that monsoon is arriving late by even up to 2 weeks in our country, in many parts of the country, and going late. So the season itself is shifting. When the season is shifting, it has a huge impact on the availability of water, not only for human beings for drinking water, but for the agriculture, which is of course the largest user of the water available on the earth. And for so, what I will add to what the other dignitary has said, that this global warming is going to continue, sir. This is not going to stop in next 1 decade, 2 decades, 3 decades, 4 decades. We have to find our ways to adapt to it, to minimize its impact, negative impacts, and to save our community from loss of the life or so from loss of the property. Huge loss of life is happening every year. Flash floods are now a common phenomena. This year, Amarnath Yatra. Who heard that the flash flood will occur in the cave where there is hardly any rainfall being observed? It is a dry mountain. But this year, because of the flash flood in there, lot of loss of life has happened. Loss of property and damage is happening equal to even 1% of the GDP of the country. Due to the climate change, if we get a drought in a year, the availability of water is not only affected for crops, but even for drinking water. There is a report which suggests that a 10% decrease in the rainfall will result in 50% decrease in the crop yield. And crop yield decrease means our food security will become at stake. So therefore, we in the scientific community, like India Meteorological Department, Ministry of Water Resource, and all scientific communities, had to have developed strategies to adapt to this climate change. What are the changes occurring in the extreme weather events? We have to find the ways to predict them as early as possible, so that the communities can be informed, the people can be informed, government can be informed, and we can save our loss of precious life as well as property and damage, and use this whatever water is available to us. It is only 6% or 4% of the entire water available in the globe. We are 16% of the population in the globe. So already our water is under stress. The per capita availability of water is under declining because of the increasing use of water for urbanization and industrialization, population increase, and so many other related factors. So this is a wonderful session. We will be learning, or you can say listening to the participants, and I hope that we can come out with some strategies within our scope of or domain to tackle with this climate change and global warming, which is changing our temperature, rainfall, and any day-to-day, even threatening our day-to-day living. So thank you with this.
Thank you so much, everyone, for your kind words and addressing the audience. Moving on, we have our next part, which is the experience sharing on impacts of climate change and adaptation strategies by people from across the states. So now, for the first presentation and experience sharing from Uttar Pradesh, we have Shri Yogesh Kumar, Additional Commissioner, MGNREGA, Department of Rural Development, Uttar Pradesh. I request him to please come up on the stage to share his experiences. Panel discussion. Can I invite? Just a small change that first we will invite Ms. Shilpa Nag, CT, Commissioner Department of Rural Development, Karnataka, to please come up on the stage and share her experiences. Thank you so much. Can we have a huge round of applause, please?
Can we have the presentation, please? So very warm good morning to all of you. I'm really happy that our Secretary, sir, is here today, and warm welcome to all the dignitaries. Really happy to be presenting about NREGA from the state of Karnataka. I am Commissioner Rural Development, Government of Karnataka. I've been in the post for 1 year, and there's been tremendous changes that are happening in NREGA all over the country, and especially in Karnataka. So to talk about NREGA, which is the Mahatma Gandhi National Rural Employment Guarantee Scheme, it is the largest employment guarantee scheme for unskilled workers across the world. So in Karnataka, last year our target was 13 crore person days. In NREGA, we kind of account for progress in person days. And Karnataka achieved 16.4 crore person days. So this year again, it is 13 crore person days. I'm sure Government of India will increase according to the requirement. It is a very grassroots-led, demand-driven program. And apart from unskilled employment, I feel that NREGA is one of the major contributors for employment as well as asset creation in rural areas in the country. So NREGA was started with a vision of reversing rural migration because a lot of rural population were not getting jobs in their own villages and cities, and they were migrating to urban centers for employment. And NREGA aims to reverse the trend to get their jobs in their own this thing. And especially the focus is on women to get employment in their own villages. And also the stress is on disabled population and senior citizens. I must say that for disabled population and senior citizens, for 50% of work, they get 100% of wages. In Karnataka, it is 309 rupees per day wage for NREGA employment. And it's a very huge scheme. In Karnataka, I must say that we have around 7,000 crore expenditure per annum in NREGA. And why it is important today is that it is one of the major programs that is also aiming at natural resource management. So when we talk about natural resource management, 65% of NREGA funds must and should be spent on NRM works, whether they are community works or individual works. So in Karnataka, 4,750 crores of rupees is spent per annum on natural resource management work. So for mitigation of climate change and other extreme climate events, NREGA has become a backbone in most of the states in the country. Yeah, next. Who's moving the presentation? Can we go next? So I think I have a lot of slides on disaster management and climate events, which I think the enlightened crowd is already aware of. So let's directly come to the solutions. Next. So basically, I believe that India is a country where there is a three-tier Panchayat Raj system, which is local self-governance at the rural levels. So Gram Panchayat should be at the forefront of actually encountering and tackling with these disaster management and climate-related events. And I think NREGA is a very important tool to do that. Next. Next. Can I have a pointer myself? Can I have it myself? Yeah. We all know the challenges that are there, due to climate change, extreme weather events. I think a lot of dignitaries were mentioning already who are experts in their fields about delayed monsoon. And even if the monsoon is there, there are extreme climate events. There are flash floods, and especially in these mountainous regions, like Karnataka has Western Ghats. So we have 5 districts with Western Ghats that experience landslide issues and all that. And there are a lot of districts in Karnataka, especially in the north, which has drought issues. So a lot of issues are related to climate change directly and indirectly. So basically, we have arrived at a lot of practices. NREGA in Karnataka has been doing very well. And considering the importance of natural resource management works, what we realized is that there was a lot of delinking between planning and implementation. So basically, planning is very important, right? From building a house to everything, planning is like top priority. But when it came to a lot of plans, sir was mentioning about the GPDP, the Gram Panchayat Development Plan. So NREGA planning was a little divorced from the implementation process. So we have come up with a scheme and a program wherein planning is actually linked to implementation so that there is effectiveness at multiple levels. So I'll directly go to the solution. So basically, we have started a program called Jalasanjeevani. Jalasanjeevani is NRM planning of NREGA works in Karnataka. So basically, planning was always a tech-oriented approach. NREGA in Karnataka has 6,000 outsourced and other employees who are working in the state. So we have technical people, we have elected representatives, we have administrative officers. So the thrust was to bring all of these people together so that the planning can be scientific and usage of technology, especially geospatial tools, can be utilized. And in Karnataka, like I was mentioning, flood, landslides, and drought are the major disaster management events. And NREGA is very comprehensive. And for those people who are outside NREGA, it is a very demand-driven approach. And basically, I think it is one of the most flexible schemes in the country. Unlike, for example, if you take the 15th Finance Commission scheme, it is 50% tied and 50% untied. So 50% is kind of dictated as to what you have to use it for. But in NREGA, it all depends on the individual requirements as well as the community requirements. So there is a lot of flexibility in implementing schemes that is beneficial for the village economy. So, for example, if we look at drought prevention works, like I was mentioning, north of Karnataka is very, um, drought affected. So in that, there are a lot of works. You can see the list of works that I've already given: contour bunding to trenching to contour cultivation, bench terracing, graded bunding, gully plugging, check dams, gabion structures, injection wells, dug well recharge, village pond or tank. Like sir was mentioning, Amrit Sarovar is one of the major schemes of Government of India, where we're taking 75 water bodies per district. So in Karnataka, we are taking 2,325 water bodies. Already we have identified 4,500 water bodies which will be taken up only through NREGA, and also sometimes in convergence with other schemes, we are taking up drought preservation measures. Okay, for flood mitigation, we have a lot of individual works, including construction of stone peripheral farm or field bund, construction of stone graded bunds, wasteland or fallow land leveling, drainage of waterlogged areas, to construction of all these community works, including diversion, stormwater drain, Gibeon check dam, boulder check dam, and all that. So a lot of individual works are permissible in NREGA. I feel that in India, NREGA is a major contributor to this. So when it comes to landslide prevention, hilly regions across the country are prone to landslides year on year. So right from afforestation to roadside plantation to contour bunding, trenches, vented dam, flood control walls and bunds, we have a lot of works. And if we look at Karnataka, we have done a vulnerability mapping of Karnataka. Karnataka State Disaster Management Authority gives us data about which regions and which areas are prone to all these kind of natural disasters. So you can see that the coastal parts of Karnataka, left side is the Arabian Sea, and we have 31 districts in Karnataka. Basically, the Western Ghat regions like Uttar Kannada district, the Shimoga district, Udupi, Chikmagalur, and Kodagu district, basically they are prone to landslides. So we are taking up these works, and along with that, some kind of civil works like footbridges for children to cross across streams when there is monsoon and all that we're taking up. So a lot of works that we have completed, it is mainly a progress of NREGA works in employment generation and wage payment and asset creation. 21-22, you can see that the number of completed works under NREGA in Karnataka is 4.92 lakhs. Where am I pointing it? Okay. So we have already desilted around 49,751 lakes, and we have built 282,000 trench cum bunds in farmers' agricultural fields. So Kalyanis is a concept which are local reservoirs and water bodies, which were traditionally there for supplying drinking water to villages. So around 1,000 plus Kalyanis have been rejuvenated, 3,400 check dams in the last 3 years, and around 1,62,000 hectares of afforestation work we have done under NREGA in Karnataka. So these are a few of the pictures of some NRM activities. So Krishi Hondas is farm ponds in individual farmers' agricultural field. So a lot of that horticulture area development, construction of cattle shed, which is an important source of livelihood for the rural population, agricultural godowns and structures, sericulture development area. You must be very familiar with the Mysore silk in Karnataka. So sericulture is a big thing in Karnataka. So including that, we are giving benefits under NREGA. So these are the other livelihood structures that we have given in Karnataka. So we also started childcare center for NREGA workers' children in Karnataka. I think that is a very supporting activity that we are doing. So just to emphasize the importance of the budget in NREGA, especially for NRM works, in 2019-20, we had you all know that 65% is the minimum permitted percentage. So more than 65, we can do how much ever. But 2,848 crore was spent on NRM expenditure in 1920. When it comes to 2021, we spent 4,170 crores under NRM in NREGA, and 21-22, 4,793 crores. So usually we spend around 4,750 crores on NRM works in NREGA. So the basic thing is that the planning has to be scientific using geospatial technologies, and every asset that is created has to be properly situated and located, and it has to be durable. Otherwise, there is a lot of soil works, for example, a lot of times we think that NREGA is about, digging a pit or desilting a lake and all that. So there are like around 290 works in NREGA. So we don't have to focus on one or two works. We have to do works which are important, which are relevant, which are part of a larger plan, and which are durable. Okay, I think because of shortage of time, directly I'll be going into our Jalasanjeevani program. A lot of activities that we have done is already given here. Okay, we have done a lot of impact studies also. One of the impact studies we are doing is with UNDP right now, so that we know where the money is being spent and whether it is effectively being spent. So basically, the highlight of today is I want to talk about our program called Jalasanjeevani. Basically, Jalasanjeevani is planning of natural resource management works using remote sensing and GIS-based technology. So this is the logo of Jalasanjeevani, wherein we have three elements: environmental conservation or greening, that is represented by green; water conservation, that is represented by blue; and soil conservation, that is represented by brown. Because soil, again, agricultural productivity, soil moisture content, a lot of elements are related to soil. Can we have the presentation back? So we are following a Ridge to Valley concept in Jalasanjeevani. So as you're aware that every district has a district irrigation plan. So basically, whatever NRM planning happens, it has to happen in accordance with the Ridge to Valley planning. So we have taken the upper ridge, middle ridge, and lower ridge. And any planning can't be for an annual year, because when you look at all the gaps that are there in a particular district, it will be a perspective planning. So it must be a 2, 3, 4, or 5 years that we need to kind of saturate that, Gram Panchayat or a village. So we are going for Ridge to Valley planning. Just give me 2, 3 minutes, I'll finish it. Yeah. I'll just give you 2 minutes, okay? A lot of people haven't come, so it's okay. Yeah, this is what we're doing. So we are dividing the basin into 3 parts, every Gram Panchayat. At the end of the day, we must understand that a Gram Panchayat is an administrative boundary. So a natural boundary may be beyond the Gram Panchayat. So we are doing a ridge to valley planning of upper ridge, middle ridge, and lower ridges. And effectively, we want to treat this in the next 3 years. So this is the most important slide. We are doing this kind of Jalasanjeevani planning in 2 factors. One is the participatory planning approach, where we kind of go for a community-based approach, which includes door-to-door demand collection, as well as a PRA and a transit walk, participatory rural appraisal and a transit walk, to understand the needs of the community, as well as a scientific planning site where we use geospatial technologies like the Bhuvan portal, where we have the GeoManrega completed works and the Bhuvan portal, as well as the Karnataka GIS, where the assets are already mapped. And for ground truthing, we are using CLART app, which is developed by the Foundation for Ecological Security. So CLART app is a very simple mobile application. It can be used on a mobile or a iPad, wherein everything is divided into 4 regions: red, blue, green, and purple. So whatever soil nature, the rainfall conditions, climatic conditions, which Narega work is actually should be done in that region, and exactly where it has to be situated will be known. So after doing a tabletop planning using Karnataka GIS technology and GeoManrega, we will be taking it to the ground to do a ground truthing. On parallelly, we'll also be doing a participatory planning, and both of them will be integrated and placed before the Gram Sabha, Ward Sabha and the Gram Sabha, for approval. And I must say that Karnataka has been doing very well in DPR e-governance. For the last 5 years, we are placed first in the country by Ministry of Panchayati Raj when it comes to our e-governance technologies. Sir must be aware that Panchatantra 2 is something which we have developed and rolled out also. So our entire planning is uploaded on Panchatantra 2, so that there is stringent monitoring right from the state level to the district and taluk levels. So these are the technologies we are using, and because of paucity of time, I think I'll just skip this. Dishank mobile app is of the revenue department. So we have a lot of technologies, and we have trained everybody in Karnataka. We have identified 20 master trainers in every district, and then we have given block level training also. And recently we conducted a Gram Panchayat level training with our ACS for all the Gram Panchayat Sarpans and the members of the Gram Panchayat and the Panchayat development officers. So this is something which within the next 3 years we are taking up. So multiple layers that we'll be using for planning. And I think any state or anybody who wants detailed information, I think I can provide them later. So these are the map matrix and the NRM activities in non-agriculture land, agriculture and livelihood and habitats we have subdivided. And the kind of feature, whether it is a point, line or polygon, and the thematic maps we have already mapped. So this will be actually done at the state level and up to the Gram Panchayat level. So I was talking about a 3-year implementation idea. So 23-24, right now we are doing it for the next 3 years. 23-24, the top 33% of the Ridge to Valley concept, all those works will be completed. And in 24-25, the middle layer will be completed. These includes all these works. And in the 3rd year, the valley layer will be completed. So this is something we have taken as a standard in the entire state. So this is an example of a Gram Panchayat level plan. This is how it will appear in KML file. I must also mention that GIZ has been a great support for the state of Karnataka. We actually took their partnership in 2 districts, one Tumkur and Shimoga, one water deficient and water sufficient district. And I think we have escalated that, and we would be more than happy if the cooperation and coordination can continue further. And since I have a person who's, I needed to talk about grazing land. Can you give me 2 minutes because this is important? Okay, okay. So we were also looking at a grazing land development plan, a disaster management sub-plan, and a wildlife sub-plan. Every Gram Panchayat will have 3 of these sub-plans. And because of extreme paucity of time, I think I'll be winding up the presentation. But I'll be more than happy to share the presentation and any inputs to any state or organization. So thanks a lot. Thank you.
Thank you, ma'am. So I request all the speakers who are presenting to please stick to your time. It's 8 minutes each for each speaker and presenter. I repeat, it's only 8 minutes each for each speaker and presenter. So now I request Shri Yogesh Kumar, Additional Commissioner, Department of Rural Development, Uttar Pradesh, to share his experiences from UP. Thank you.
Morning, everyone, and with the permission of Chair, Secretary Amawadi present here with his blessings. Manrega has been doing very well in the entire country, and I'll take you through what journey Manrega has covered so far. And Manrega abhi filhal, it is 16-year-old. It was started in 2006. Now it has covered the 16 year of his age. And while I joined Manrega department, it was the budget of Manrega used to be 40,000 crore. And under the guidance, under the supervision of Honorable Secretary, sir, it has reached to 1.11 lakh crore. It is ranging between 90,000 crore to 1.1 lakh crore. So already my fellow speakers have spoken about, we can start this presentation, please. This is a map of UP. We start from here. Take it back. I'll not speak on this. We cover 75 districts, 825 blocks, 58,000 Gram Panchayats in Uttar Pradesh. Manrega in the entire country covers 676 districts, 6,600 development blocks, and 2.6 lakh Gram Panchayats. Today in Manrega, in the country, 81 lakh labor are working. And to my estimation, I think almost 70% of total Gram Panchayats covered under Manrega are working today also. Manrega has reached deep down till the level of Majras, till the level of those hamlets. So Manrega का जो reach है, वो expanded है. It is very, very wide. So we must understand कि Manrega जो especially for the climate adaptation, people participation ensure करने के लिए, this is the most effective program. Now we go ahead, please. Next. We know okay, how what climate change is, so I'll not spend time here. Please go ahead. What causes climate change and what are the effects, and what are the impacts on displaced people, poverty, loss of livelihood, hunger, malnutrition, etc. So these are the impacts. Let's go ahead. Next, please. This slide shows how Mahatma Gandhi Narega can contribute to counter this climate change. There are, we can say, pie is divided into 4 pieces. Barring industrial processes, 24%, the 3 remaining 76% are covered under Manrega. And this way we become, can I have the codeless mic? Is there? Burning fossil fuel, then agriculture and deforestation. ये वाली सारी एक्टिविटीज जो है इसमें जो एग्रीकल्चर एरियाज हैं बेसिकली यूपी हैज 80% ऑफ रूरल पॉपुलेशन एंड इंडस्ट्रियल प्रोसेसेस आर रिमेनिंग 15 to 20%. इसमें सब में 264 एक्टिविटीज मनरेगा में होती हैं जिसमें 85 एक्टिविटीज एग्रीकल्चर रिलेटेड हैं, एनआर रिलेटेड हैं. वो सब की सब इसको वास्टली कवर करती हैं. नेक्स्ट गो अहेड प्लीज. यस. My colleague Shilpa explained already what kind of exhaustive thing are covered in Manrega. And segregated activities भी इसमें like coastal areas, be it mountainous areas, be it plain areas, इसमें सब के सब जो segregated activities हैं, type of classified activities मनरेगा में cover की गई हैं. सेंट्रल गवर्नमेंट बड़े सारे इनिशिएटिव इसमें इस समय लिए हुई हैं एंड जीआईजेड स्टेट्स को सपोर्ट करके मीन्स वी आर इंडीड वी आर इन पोजीशन to now support this process of climate change or to counter this the process of climate change. We are means well confident, and I am expecting, yeah, I can very well say कि given the kind of availability of budget, given the kind of willpower of the central government, state government, and given the kind of technological platform now and people's participation, इसको easily हम लोग अगले 10 से 15 साल 20 साल में इसमें heavily contribute कर सकते हैं. Next please. यूपी में लास्ट 6 years में 6.34 lakh water conservation works have been carried out. Water conservation was 1.73, then watershed development 60,000, irrigation related works 3 lakh 15,000, water bodies renovation 85,000, and total works in last 6 years in UP have been carried out to the tune of 6.34. ये सब के सब वर्क जो हैं, they have combination of like soil work as well as metal work. We understand that metal component in Manrega is scantily available. It is to the tune of 20-25%, which affects the quality of assets. But still, with the like convergence of like PMKSY, be it like Panchayati Raj funds, we try our level best. The asset remain durable for minimum of 10 years. Next, please. Apart from the Jal Shakti, or apart from the Amrit Sarovar, which I'll come to in the like in a while, there were Million Wells Scheme, Mission Water Conservation Scheme, then Jal Shakti Abhiyan, which was started in 2019. For last 6, 7 years, 8 years, we've been watching. There have a lot of efforts like being put in into this water conservation area. The Jal Shakti Abhiyan was started in the year of 2019, and the targets which were given, countries like all the states, they liberally and they successfully they achieved all those targets. Next, please. UP did like out of target of 11,000 in 35 districts where it was implemented, like it was Jan Shakti Ban was carried out. We completed 18,235 assets. Next, please. In Amrit Sarovar, which was launched just 4 months back, target was moderate, I think 5,600 for UP. We have started 22,000 ponds so far. We have completed 8,500 ponds so far, Amrit Sarovars, and we are like almost we are topping the country in terms of completing, starting, and focusing on this activity, which is guided by the inspiration and the guidance for of Honorable Prime Minister of country. Yes, next please. This is the slide which shows how UP has fared, and other states are also faring well. As sir said, it was 50,000 only, and 98,000 works have started. So I'll show you how UP has fared in this. This is the scattering of Amrit Sarovar. Here, the point which needs to be understood, which needs to be noticed, the upper part of UP's this shows the western part, which is Baghpat, Ghaziabad, Noida, where we are sitting here, Gautam Budh Nagar. So concentration should have been here, more here, because water table are falling on this side. And the lower part shows maybe this Bundelkhand area. So इसमें ऊपर वाले part में, because Manrega is not very effectively running, maybe demand is low, people are not coming up. This entire part of western area, they have been made by the funds of either Panchayati Raj, urban development, CSR, those funds have been pulled in. So this specific activity, this activity in UP, we are trying to cover in a segregated fashion, keep development areas, how they will be covered, then like those Bundelkhand, then Vindhyachal, Western UP, and Central UP. So this shows how so far have come up. This will intensify. I believe that given the approach, like our government is focusing in one GP, there will be 2 Amrit Sarovar. This entire map will be completely blue. Next, please. This is the Amrit Sarovar of Hapur. Next, please. Amrit Sarovar in Gonda, district Gonda. Next, please. District Gonda is flood affected. It is closer to the Nepal's border. Rampur Patwai, it was discussed and it was highlighted by Honorable PM also in his Man Ki Baat speech. Next, please. This is from again Gonda. Next, please. One, linear water bodies, which is like also requires be it bamboo plantation, be it strengthening of the of bonds, and the like, creation of water bodies in 2 kilometers left hand side of river banks or these water bodies bank. The UP took these linear water bodies of local nature of like of the length of 50 kilometers to 200 kilometers. We started this journey in 2019 or 2018-19. We took just 5 those linear water bodies. Then this year we are focusing on 75 such water bodies in alignment with our technical institution, IITs and NIH Roorkee, BBAU Lucknow, and GIZ also has participated in selection of 14 water bodies. They are preparing DPR, they are giving us handholding in technology, and they are ensuring the mid-course corrections and final reviews. So this is a flagship thing which we are carrying out for the purpose of climate mitigation and water security. Next, please. That is the Mandakini River. It is in Chitrakoot. Its white portion shows in the month of 2017-18. It was the first stage, or this river was taken 4 years back. Green, this white portion shows that there was sand accumulated at this stretch, and after the work which was carried out for 1.5 years, the portion was turned it was turned black, and this black portion shows clearly the water availability in the around the same month. This is a picture of pond, this Amrit Sarovar. Next, please. This have been appreciated in Mann Ki Baat variously. We have got awards also on this, Kalyani, Barabanki, and Noon River in Jalan on different dates. Next, please. This is Kanpur Dehat. Yes, next, please. Pandu River, Sirsa River, Firozabad. Next, please. Puruha, Itawa. Next, please. Manwar, Gonda. Next, please. Kunwar, Jaunpur. Next. Naad, Varanasi. Varuna, Varanasi. Kalyani, Barabanki. It was discussed by Honorable PM. So this was just a selective few pictures. I should say all 75, like maybe 30 rivers we have not collected. So we have been awarded also by Ministry of Water Resources on these works. Other than this, used water management in terms of like creating the soak pit and recharge pits. Next, please. This is how like structures are made, and these are given to individual beneficiary. They cost around 12,000, 15,000 rupees per beneficiary. Next, please. Soak pits. Next. Other activity which is important is rooftop rainwater harvesting. It was introduced 2 years back. Biogas has come this year. Next, please. This rooftop rainwater harvesting. This is also being taken in UP liberally and systematically. All the government buildings, all the primary schools, all Anganwadi canes, they are being covered by rooftop rainwater harvesting. It was tweeted by Honorable Minister as well, a work which was done in District Barabanki. Next, please. This is the work which has been done in District Barabanki, and it costed 1.1 lakh rupees only. And it is like is giving the due purpose. It's resolving the issue. Next, please. Yes, next, please. There's awareness is the key. So we try to spread awareness through our schools, Anganwadi canes, through our like CSOs, NGOs, among the children, among local people, and especially the communities which are doing agriculture and husbandry. Next, please. These are the awareness pictures. Next. Plantation is also taken extremely aggressively and liberally in UP in last 5-6 years. How Manrega has contributed to the plantation in UP. Like in 18, it was moderate 78 lakhs plants saplings only, which were planted. But coming down in 2022-23, 12.32 crore plants was those saplings were planted during the current year. It's an aggressive strategy taken by the UP government, and of all the entire target of the government, 1/3 is given to Manrega. And here, what we face, the problem, we have not been like in Manrega, we cannot provide any kind of fencing or any kind of tree guards. So generally, the trees remain vulnerable to the local I should say those animals or these like milching animals, and we find it slightly difficult to save them. Though there is a provision of like providing manpower for the purpose of maintenance, but if at all this like providing protection to the trees can be included in the activities, permissible activities of this plantation, that can be helpful. And plantation as well as farm pond, which is again a water conservation activity, should also be given for, especially for the middle level, those farmers and the large farmers. Because smaller farmers and like SFMF, those marginal small farmers, they don't have sufficient lands for like planting trees in the block plantation form, and in linear they can do. But in block plantation, they are very reluctant, and even farm pond also. But those large farmers and small farmers are not covered, which requires a policy like thinking as well as a policy decision that large farmers and middle level farmers also can be given consideration for the purpose of these two. Next, please. Yeah, plantation activities. Next. Next. These are the awards which were given by Ministry of Water Conservation and Water Resources. Next, please. Coordination is a challenge in the with all the administrator. We also face this challenge. They are the few, I should say, list which department need to coordinate in order to ensure water security, or in order to ensure Manrega or convergence efforts are successful. This is just an illustrative list, and they must be double if at all we go. This 13 point citizens awareness and unforeseen. So, iske coordination ke liye what I am finding ke until unless the databases are like integrated, it is not going to solve our problem. Like convergence, just sitting together and like manual convergence is not working well. Next, please. These are the like role of GIZ and role of other like all participant. This planning has to be participative, mutually agreed upon COP model, then equal understanding of all stakeholders right from the center till the GP level. Accessibility on single touch and single click GIZ has helped us in this a lot. Mid-course reviews, obligatory, like GIS planning we have made with the help of GIZ, but that obligation part, like it has to be made the part of MIS of Manrega, that is still like to be done. So next, please. This is again a few things. We can skip it. Yes, next, please. What may not work, this is the last slide actually. A scattered, uncontrolled, decentralized way of planning will not work, especially when we're handling a geography or a large landscape. Administrative units cannot work. This has to be geographically, we have to understand the nature in a geographic manner. And especially MIS, Government of India has a MIS which is uniform for Sikkim, Manipur, Punjab, Haryana, Uttar Pradesh, Rajasthan. It gives a uniform kind of look of all the data. We are the different states, like we understand the coastal areas and hilly and as well as these plain areas. We require some specialized MISs, and those MISs should interact with urban, like maybe revenue, maybe animal husbandry, maybe Panchayati Raj. This a unshared, uninteractive, uniform, and MIS which is not dynamic, which is not changing as per the needs of like time. That thing is not like working well, or maybe it's not like giving us desired results. So this much from my side. Thank you very much, all of you.
Thank you so much, sir, for sharing your experiences and strategies from Uttar Pradesh. I now invite Mr. Anshul Agarwal, MIS in charge, to share his experiences from Madhya Pradesh. Can we have a huge round of applause for Mr. Anshul Agarwal?
नमस्कार सर, नमस्कार सभी को, नमस्कार सभी मेरे fellow participants को. Can I have the advancer of this? Thank you. आज हम सभी यहाँ पे जो मनरेगा का रोल है क्लाइमेट चेंज में स्ट्रेटजीज जो भी हम लोग अडॉप्ट कर रहे हैं उसको डिस्प्ले करने के लिए उसके लिए गैदर हुए हैं. अब जैसा कि हम सभी जानते हैं मनरेगा जो है उसका प्राइमरी गोल है मिनिमम 100 days of wage employment to the rural needy persons, then durable assets generation और livelihood enhancement. मनरेगा में हम सभी को पता है कि 262 permissible activities हैं, out of which 182 are NRM based activities and remaining are non-NRM based activities. And these 182 activities cover the water-related 85 works, plantation works, and rest are land development works. These are the activities which are taken in Madhya Pradesh to mitigate climate change. The primary activity is the groundwater intervention management plan. These are the groundwater intervention management plans prepared in Madhya Pradesh to meet this climate change, for the mitigation of this climate change. We are planning the NRM works which are based on, this planning is based on GIS based and remote sensing tools. Then we have several plantation activities like Devaranya. This is medicinal plantation. Then we have CNG. This is community nutrition garden. Then we have bamboo plantations. Then there are Miyawaki plantation. This is very helpful in mitigating climate change. This heavily reduce the carbon footprints, this activity. Then we have social forestries. This is Udyan Se Uthan. We are engaging self-help groups in this plantation activity for livelihood enhancement. Then we have several other plantations also. Apart from these activities for water rejuvenation, we have Amrit Sarovars. This activity is central government's primary plan, and then we have Pushkar Dharovar Samriddhi Abhiyan, in which we are rejuvenating the old tanks which are already constructed but are जीर्ण शीर्ण हो चुके हैं, जो उनको rejuvenate करने की आवश्यकता है. Then we have several other water structures which are implemented, which are identified in the Catch the Rain Abhiyan, which was implemented in 2021 and 2022 as well. As we all know, there are 5 P's of sustainable development. The first one is people. So in Manrega and Madhya Pradesh, we are targeting people. We are providing livelihoods to them. We are supporting their livelihood. Then we are in second stands for planet, for the rejuvenation of soil and water resources. We are doing works like these water harvesting structures. Then we have plantation, afforestation. Then partnership. We are engaging several knowledge partners in Madhya Pradesh. These knowledge partners assist us in the better implementation of our projects, and also provide continuous support so that the quality of the assets developed are better. Then prosperity. By providing assets like Kapil Dhara and several other structures, we are enhancing the livelihoods of the poor families and poor farmers. Also, there is the last P stands for peace. ये पीस से अर्थ है हमारा, जो हम वुमेन एम्पावरमेंट के क्षेत्र में भी काम कर रहे हैं. हम जितने भी एसएचजीज हैं, हम वुमेन मेट्स को ज़्यादा ऑर्गेनाइज करते हैं. वुमेन ओरिएंटेड एसएचजीज ज़्यादा होते हैं हमारे, ताकि उसको हम ज़्यादा टारगेट कर सकें. देन फर्स्टली हमारा जो जीआईएस बेस्ड वाटर इंटरवेंशन मैनेजमेंट प्लान्स हैं, उसका एक ब्रीफ आपको दे रहा हूं मैं. इसका जो मेन नेसेसिटी है, हमारा जो इनएडुकेट सरफेस वाटर है, उसकी डिमांड्स को मीट करने के लिए ये इसकी आवश्यकता है. देन जो हमारा ग्राउंड वाटर लेवल धीरे धीरे डिक्लाइन होता जा रहा है, उसको मीट करने के लिए, और अवेलेबिलिटी ऑफ ग्राउंड एट स्पेसिफिक प्लेसेस. हमारे यहाँ कई ऐसे प्लेसेस हैं, हम बुंदेलखंड एरिया भी हमारे यहाँ फॉल करता है. बुंदेलखंड एरिया में पूरे अराउंड द ईयर पानी की अवेलेबिलिटी होती ही नहीं है, तो उसके कारण ड्रिंकिंग वाटर का तक इशू हो जाता है. तो ये सब प्लानिंग हमारी उसको टारगेट करते हुए भी है. देन द अदर एडवांटेज ऑफ इट इज एग्रीकल्चर प्रोडक्शन इंक्रीज होगा, हमारा इरिगेशन बेटर होगा. At present, out of 313 blocks, we have already prepared the plans of 172 blocks, which includes the plans of 81 semi-critical, critical, and overexploited blocks. This is the geographical map of Madhya Pradesh, in which we are showing that there are around 84 semi-critical, critical, and overexploited blocks. 233 blocks are such which are at present set safe blocks. But if we do not treat them properly, then in future they can also come under this semi-critical or critical section. So we have prepared the plans for these semi-critical, critical, and overexploited blocks, and we are in process of preparing the plans for safer block as well. At present, we have completed 172 blocks. We have also been in a convergence with PHE department. With PHE department, there is a scheme called Nal Jal Yojana, which is targeting to provide the water source of water, drinking water to every household. लेकिन हमारे यहाँ करीब 1638 ऐसे विलेजेस हैं जहाँ पे अभी तक कोई प्रॉपर सोर्स ऑफ वाटर नहीं है. तो ऐसे विलेजेस के लिए हम लोगों ने ही प्लान्स बना रहे हैं, ग्राउंड वाटर इंटरवेंशन मैनेजमेंट प्लान, आउट ऑफ विच 1350 अभी तक हम बना भी चुके हैं. और इन प्लान्स में जो स्ट्रक्चर्स निकल के आ रहे हैं उसमें जो स्ट्रक्चर्स हम नरेगा से टारगेट कर सकते हैं वो हम नरेगा से कर रहे हैं, और रिमेनिंग स्ट्रक्चर्स विच आर नॉट परमिसिबल फ्रॉम मनरेगा आर बीइंग टेकन अपॉन बाय पीएचई डिपार्टमेंट. ये हमारा मैकेनिज्म है जो अभी तक हमने अडॉप्ट किया है ग्राउंड वाटर इंटरवेंशन मैनेजमेंट के लिए. सबसे पहले हमने जो इनिशियल फेज में एमओआरडी ने हमें कहा था, तो हमने इनिशियल ट्रेनिंग देके 2 मास्टर ट्रेनर्स पर डिस्ट्रिक्ट करके 2 ग्राम पंचायतों के प्रति जिले प्लान्स बनाए थे. देन फिर हमने मूव करके उसको जीआईएस प्लानिंग पूरे स्टेट की करी, जिसमें सारे 22,777 ग्राम पंचायतें थीं. लास्ट ईयर हम लोगों ने फिर वाटर बजट्स प्रिपेयर करे थे सारी ग्राम पंचायतों के. हमने जीआईजेड वास्का की मदद से सबको ट्रेनिंग दी थी. उन ट्रेनिंग के बेसिस पे हमारे सारे ग्राम पंचायतों के वाटर बजट बने. देन फिर हमारी टीम ने उन वाटर बजट्स के अगेंस्ट में जो प्रिपेयर्ड जीआईएस प्लान्स हैं उनका क्वालिटी चेक्स किया, और उनके क्वालिटी चेक्स में जो हमने पाया कि वो जीआईएस प्लान्स एडिक्वेट थे भी कि नहीं उस वाटर बजट को मीट करने के लिए. तो अगर जहाँ पे नेसेसिटी थी हम लोगों ने वास्का के साथ फिर उनको ट्रेनिंग दी और उनके क्वालिटी इंप्रूवमेंट की तरफ काम किया. बाय द बिगनिंग ऑफ दिस ईयर हम लोगों ने ग्राउंड वाटर इंटरवेंशन मैनेजमेंट के कंपोज प्लानिंग की तरफ ज़्यादा फोकस करा है, जो कि कंपोजिट लेवल पे, ब्लॉक लेवल पे हो रहा है. इनिशियली हम लोगों ने इसमें 84, जैसा कि मैंने स्टार्टिंग में बताया था, सेमी क्रिटिकल, क्रिटिकल ब्लॉक्स की तरफ टारगेट किया था. और इसमें हमने 132 मास्टर ट्रेनर्स को भी ट्रेन किया था, जिनकी मदद से हम लोगों ने ये बनाए थे. अब हम टारगेट कर रहे हैं पूरे 313 ब्लॉक्स के प्लान्स प्रिपेयर करने के लिए, और बाय द एंड ऑफ नेक्स्ट 2 months वी विल बी एबल टू डू इट. These are some of the photos of the trainings we have conducted. These tutorials which were given by Vaska and our team are also available on the council's website, which are accessible to anybody. These are on public domain. There is reading material and video tutorials as well. This is the approach we have taken. This is the scientific planning process based on GIS maps, in which we have followed the basic principle of bridge to valley approach. Then we have identified all the permissible works under which were necessary for the preparation of those plans, and on those in those work NRM activities are all included. This is the basic plan of one of the Bundelkhand area block, Damo. My colleague will say a few words about it.
नमस्कार, मैं अनुराग राजपूत दमोह ब्लॉक से बिलोंग करता हूँ. डिस्ट्रिक्ट दमोह है मेरा. ये जीआईएस प्लान है हमारा, हमने जो बनाया है. इसमें हमने इस प्लान में बनाने के लिए हमने पूरा पंचायत बाउंड्री की यूज़ के साथ साथ हमने यहाँ पे 5 प्रकार के मैप जो हमारे होते हैं, बेस हाइड्रोलॉजी मैप, जियोमॉर्फोलॉजी मैप, लिनियमेंट मैप, जियोलॉजी मैप, वाटरशेड मैप, इन 5 प्रकार के मैप का यूज़ करके हमने एक ब्लॉक का एक सैचुरेशन प्लान तैयार किया हुआ है. जिससे ग्राउंड सारी एक्टिविटीज़ में हमने एनआरएम एक्टिविटीज़ पे सारा वर्क किया हुआ है. कैसे हम हमारे फर्स्ट ऑर्डर, सेकंड ऑर्डर, थर्ड ऑर्डर के हम ट्रीटमेंट कर सकें, और हमारा कैसे हम ग्राउंड वाटर को रिचार्ज कर सकें. इसके सबसे पहले हमने इसमें बेस हाइड्रोलॉजी मैप से हमें इसमें क्या मदद मिली है. इसमें हमने बेस हाइड्रोलॉजी मैप से हमें जब टेबल वर्क हमने किया तो इसमें हमारे जितने भी फर्स्ट ऑर्डर सेकंड ऑर्डर के ड्रेन्स थे, थर्ड ऑर्डर ड्रेन्स थे, सारे ड्रेन्स हमें वहाँ पे मिल गए और सारे ड्रेन्स का हम ट्रीटमेंट बहुत इजीली वहाँ पे कर पाए इस मैप की मदद से। जियो मॉर्फोलॉजी मैप का हमने इसमें यूज़ किया हुआ है। जियो मॉर्फोलॉजी मैप के यूज़ से हमने हमारे पूरे ब्लॉक का, पूरे ज़िले का हमें सॉइल स्टेट वहाँ पता चल गया। तो हमें मोस्टली जहाँ पे स्टोरेज टैंक लेने थे या पर्कुलेशन टैंक्स वगैरह हमें जहाँ लेने थे, वहाँ पे हम सॉइल स्टेटा के अकॉर्डिंग हम वहाँ वो स्ट्रक्चर वहाँ प्रपोज कर पाए। इसके साथ हमने लीनामेंट मैप का भी इस पर यूज़ किया हुआ है। लीनामेंट्स मैप से हमें अंडर द अर्थ क्रस्ट जो भी हमें फ्रैक्चर्स थे, फॉल्ट्स थे, लीनामेंट्स थे, वो हमें पता चले और जो भी लीनामेंट्स हमारे ड्रेन्स को क्रॉस कर रहे थे तो वहाँ पे हम सूटेबल स्ट्रक्चर ग्राउंड वाटर को रिचार्ज करने के लिए जो स्ट्रक्चर हम ले सकते थे, ऐसे रिचार्ज शाफ्ट है वो हमने ड्रेन पे अगर हमारा लीनामेंट क्रॉस कर रहा है तो हमें रिचार्ज शाफ्ट वगैरह हमने वहाँ पे लिया हुआ है। ग्राउंड वाटर टैमिंग हमने उस पर लिया हुआ है। पर्कुलेशन टैंक हम कहाँ ले सकते थे, ये लीनामेंट्स मदद की मैप की मदद से हमें वो सूटेबल प्लेस मिल गया। तो कौन सी एक्टिविटी हमें कहाँ लेना चाहिए, उस में हमें बहुत बड़ी हेल्प मिली इन 5 प्रकार के मैप का हमें यूज़ करते हुए। तो हम पे बेहतर तरीके से हम अपने और ग्राउंड वाटर मैनेजमेंट का हम प्लानिंग इसमें कर पाए। अगला मैप हमने जो यूज़ किया है वो है हमारा जियोलॉजी मैप। जियोलॉजी मैप से हमें हमारे ब्लॉक का जो भी जियोलॉजिकल स्ट्रक्चर था वो स्ट्रक्चर हमें पता चल गया। तो इससे हमें बड़ी मदद मिली कि किस स्ट्रक्चर में हम कौन सा एक्टिविटी हम ले सकते हैं, तो वो एक्टिविटी हम प्रॉपर तरीके से प्लान कर पाए हैं। वाटरशेड मैप ये बहुत इंपॉर्टेंट मैप हम लोग के यहाँ से वाटरशेड मैप का हमने यूज़ किया हुआ है। इसकी मदद से हम लोगों ने क्या किया, एक वाटरशेड के ट्रीटमेंट पे हम काम कर पाए। जब हम एक छोटे से एरिया, एक वाटरशेड एरिया को ट्रीटमेंट हमने प्रॉपर तरीके से किया तो जब एक वाटरशेड एरिया प्रॉपर तरीके से ट्रीट हो जाता है तो एक बेहतर प्लान बनके, जब कॉम्पैक्ट प्लान जो आता है एक बेहतर प्लान बनके हमारा सामने आता है। हमने रिस्टू वैली पूरा ट्रीटमेंट इस पर वर्क किया। तो ये 5 प्रकार के मैप्स का हमने यूज़ करके कैसे हम ग्राउंड वाटर को रिचार्ज कर सकते हैं, ये हमने इस प्लान में पूरा किया हुआ है। ये प्लान हमने जो बनाया पूरे एनआरएम एक्टिविटीज हमने इस पे ली हुई हैं। जैसे फर्स्ट ऑर्डर के ट्रीटमेंट के लिए हमने एलवीसीडी स्ट्रक्चर्स यहाँ प्रपोज किए हुए हैं, गली प्लग्स हमने लिए हुए हैं। सेकंड ऑर्डर के ट्रीटमेंट के लिए हमने गेवियंस लिए हुए हैं, पर्कुलेशन टैंक्स भी हमने प्रपोज यहाँ पे किए हुए हैं। एक्चुअली क्या है कि मैं टाइम की शॉर्टेज के कारण मैं पूरा प्लान आपको शो नहीं कर पा रहा। बहुत बेहतर प्लान हम लोगों ने बनाया है, जीआईजेड का बहुत बड़ा हम लोग को मदद मिला है इसमें हमारे स्टेट में। और अभी हम लोग हमारे 84 ब्लॉक्स ऐसे हैं जो ओवर एक्सप्लॉयटेड हैं और उन ब्लॉक्स का हम लोगों ने प्लान तैयार किया और प्लान तैयार करके हम उन वर्क्स पे हम काम भी स्टार्ट हमने कर दिया है। नेक्स्ट टू
This is the basic progress which we have already demonstrated. These are the works identified in the plans prepared till now. There are around 53,000 works identified, out of which 44,000 works were permissible from Manrega, which are being taken from Manrega, or rest of the 8,719 works are being done with the convergence of with other support of other departments which are not permissible from Manrega. As I said, PHE is doing the two types of work which are recharge shaft and groundwater tamming, which is not permissible from Manrega. These are a few photos regarding the same. Fine, sir. Fine, sir. I'm just concluding it, sir. Okay. Fine. Okay, fine. Thank you. These are the photos. We have there's a Pushkar Dharwar Samriddhi Abhiyan in Madhya Pradesh, through which we are rejuvenating 50,000 ponds. There's Amrit Sarovar Abhiyan, in which it is targeted for 75 Amrit Sarovar per district, but we are taking more than that. We are taking more than 100. Okay. Through which we are increasing the irrigation potential. There are several plantation works like social forestry, Devaranya. Then community nutrition garden is being taken up. Then individual land pe plantation hai. This is Miyawaki plantation. This is the prime project in reducing the carbon footprints. This is further development. This is the final conclusion. This slides clearly shows the possible prospects of these plannings done in Madhya Pradesh. We are the potential of increasing the 46 lakh hectare groundwater management intervention plans. Thank you.
Thank you so much. Just before our next presenter, I wanted to inform that the International Water Week is organizing an Agra tour tomorrow. So for the registration, you can enroll yourself at the registration desk before 2 p.m. So next we have Mr. Arvind Saxena, Senior Executive Engineer, who will be joining us from Rajasthan virtually.
I have a special request to the speakers. Kindly try to accommodate the successive speakers. Not all the time is for you. You want to introduce many things. Well, be brief and ensure you do not repeat what your previous speaker has spoken in the other state or something. We save a lot of time and you are benefited by hearing others too. Thank you.
Thank you, sir.
Good morning, all of you. Hello.
Once again, I would like to inform that International Water Week is organizing an Agra tour tomorrow for all our delegates, panelists, speakers. So whoever is interested can enroll themselves at the registration desk before 2 p.m. today. You'll get all the details over there. So if anyone is interested, please enroll today itself. Thank you.
Good morning.
Hi, good morning, sir. Can you hear us?
Yes, I can hear. Are you hearing me?
Thank you, Arvind, sir, for joining. And there's a short technical error that we cannot see your video, but we can surely hear you.
Yes. नमस्कार सभी को. मैं अरविंद सक्सेना फ्रॉम राजस्थान, सुपरनेट इंजीनियर. As you know, Rajasthan is the largest state of India. About 10.4% is the total area from country. The northwest portion of Rajasthan is generally sandy and dry, and forest cover only 4.19% of national forest cover. In Rajasthan, there are 12 agroclimatic zones, whereas average rainfall varies from 100 mm to 1000 mm. Total surface water is only 1.16% of country. So, Mahatma Gandhi Narega Rural Employment Guarantee Scheme is very important for Rajasthan. जैसा कि पूर्व वक्ताओं ने बताया था कि महात्मा गांधी नरेगा का मेन ऑब्जेक्ट रोजगार देना और उसके साथ जो सेकेंडरी ऑब्जेक्ट है जिसे हमें मेन मानना चाहिए ड्यूरेबल असेट्स क्रिएट करना है. तो महात्मा गांधी नरेगा में राजस्थान के लिए चूंकि एनआरएम पर्सपेक्टिव ड्राई और रेनफॉल कम होने की वजह से काफी इंपॉर्टेंट है, तो यहाँ जरूरत है कि जो असेट क्रिएट किए जाएं वो ड्यूरेबल एंड क्वालिटेटिव हों. तो हमने राजस्थान में ये महसूस किया कि अगर ड्यूरेबल असेट क्रिएट करने हैं तो जो चैलेंजेस हैं वो मेन चैलेंज था प्लानिंग, प्रॉपर प्लानिंग, सेकंड था कैपेसिटी बिल्डिंग ऑफ ऑल स्टेक होल्डर्स एंड थर्ड मॉनिटरिंग एंड इवैल्यूएशन. तो राजस्थान में प्लानिंग जो शुरुआत की गई बेसिकली जीआईजेड के हेल्प से प्लानिंग शुरुआत करी गई जियो स्पेशियल टूल्स को अडॉप्ट करते हुए. जियो स्पेशल टूल्स के द्वारा राजस्थान में पायलट जो ग्राम पंचायत है उसमें पायलट किया गया था और इसको हमने जीआईएस टूल्स की मदद से और फील्ड में एक्चुअल प्लानिंग करके, जिसके लिए हमें करीबन 1 से 1.5 महीना प्लानिंग करने में लगा था उस पंचायत में, उसको जो हमने डिफरेंस को मेजर किया तो केवल 5% डिफरेंस आया था। तो एडॉप्ट प्लानिंग के लिए ये सोचा गया कि क्यों नहीं जीआईएस टूल्स को यूज करते हुए और जीआईएस के जो लेयर्स भुवन पोर्टल पर मौजूद हैं उनको यूज करते हुए प्लानिंग की जाए। इस चीज को देखते हुए राजस्थान ने प्लानिंग शुरू किया और आज राजस्थान की सारी ग्राम पंचायतों के जीआईएस बेस्ड प्लान बन चुके हैं। इसमें मैं कहना चाहूंगा कि जो राजस्थान ने काम किया उसमें हर ग्राम पंचायत का प्लान वाटर बजटिंग करते हुए किया। वाटर बजट बनाते समय ये देखा गया कि रेनफॉल कितना है, उस पंचायत की वाटर नीड क्या है, इंक्लूडिंग लाइव स्टॉक एंड इंडस्ट्रियल नीड को आइडेंटिफाइड करते हुए, और कितना पानी हम उस ग्राम पंचायत में उसके एरिया में रोक सकते हैं, जिसके लिए हमें एक्टिविटी प्रपोज करनी चाहिए। इन सबको देखते हुए जो जीआईएस बेस्ड प्लान बनाए गए थे, उन प्लान को बना के उस पर काम करना शुरू किया गया। राजस्थान में चूंकि जो एरिया है वो जियोग्राफिकल काफी चेंजेस हैं, तो ये सोचा गया कि कुछ प्लांट स्ट्रेटेजीज तैयार की जाएं। तो लैंडस्केप बेस्ड 5 मेजर जोन आइडेंटिफाइड किए गए, जिसमें एक डेजर्ट प्लेन्स है जो राजस्थान के वेस्टर्न राजस्थान में है, हिली एरियाज है, इरिगेशन इंटेंसिव एरियाज हैं जिनको आइडेंटिफाइड किया गया, रेनफेड एरिया है और रेवेनस लैंड एरियाज हैं। इस तरीके से ये 33 जिलों को इन 5 जोन में बांटा गया और 5 जोन में बांट के इनके एरिया स्पेसिफिक प्रोजेक्ट्स तैयार करने के लिए, जिसमें जीआईएस प्लानिंग को वेटेज दिया गया, जीआईएस स्पेशल टूल्स को यूज करते हुए प्लानिंग की जाए, ये करते हुए प्लान बनाने की बात की गई। इसी तरीके से एक्यूफर बेस्ड ट्रीटमेंट के लिए भी एक पायलट ब्लॉक सिलेक्ट किया गया और वहाँ नरेगा और डिस्ट्रिक्ट मिनरल फंड को यूज करते हुए रिचार्ज साफ्ट के प्रोजेक्ट लिए गए, जहां मेजर चेंजेस दिखाया गया और जो इन प्रोजेक्ट्स के होने से, उस पायलट प्रोजेक्ट के होने से उस ब्लॉक में जो ओवर एक्सप्लॉइटेड ब्लॉक था, आज उस कैटेगरी से बाहर आ चुका है वो ब्लॉक। तीसरा था फोकस ऑन डिग्रेडेड लैंड टू कंट्रीब्यूट क्लाइमेट एडेप्शन। इसके लिए राजस्थान ने एक कॉन्सेप्ट दिया एक ग्राम पंचायत के लिए कि वहाँ 4 तरीके की एक्टिविटी कोशिश की जाए, अगर वहाँ नीड है तो वहाँ एक गांव 4 काम करके एक प्रोजेक्ट लिया गया। इन 4 में डेवलपमेंट ऑफ मॉडल पॉन्ड, डेवलपमेंट ऑफ पास्चर लैंड, डेवलपमेंट ऑफ प्लेग्राउंड एंड डेवलपमेंट ऑफ क्रिमेटोरिया। तो जहां जहां ये एक्टिविटी नीड थी, इनको टेकअप किया गया। और एक था एनहेंसिंग कैपेसिटीज एंड वाटर यूज एफिशिएंसी इन स्मॉल एंड इरिगेशन प्रोजेक्ट। जीआईएस टूल्स को यूज करते हुए पूरे राजस्थान की वाटर बॉडी को मैप किया गया जीआईएस मैप पे, और आइडेंटिफाइड किया गया कि उनका जो सबमर्जेंस एरिया है वो कितना है। तो सबमर्जेंस एरिया को देखते हुए जहां ये देखा गया कि एनक्रोचमेंट है, उनके इनलेट चैनल्स बंद हैं, या जो ओवरफ्लो सेक्शन है वो टूट गया है, तो उसकी रिपेयर और इनलेट चैनल को ओपन करना, एनक्रोचमेंट हटाने के, ये सब काम आइडेंटिफाइड किए गए और ग्राम पंचायतों द्वारा उनको नरेगा में जीआईएस की मदद से उनको लिया गया। रेवाइंस लैंड रिक्लेमेशन के लिए एक प्रोजेक्ट जीआईजेड की मदद से हमने तैयार किया गया। बेसिकली उस समय कोरोना काल भी था, लेकिन ऑनलाइन ट्रेनिंग्स दी गई फील्ड फंक्शनरी को, टेक्निकल पर्सन्स को, एक मॉनिटरिंग के लिए एक ई मैप करके एक मोबाइल एप्लीकेशन तैयार कराया गया जीआईजेड की हेल्प से, और इस ई मैप पे फील्ड फंक्शनरी ने फील्ड में जाके उन एक्टिविटी को मैप किया जो वहाँ हो सकती हैं। बेसिकली इस प्लानिंग के लिए टोटल जो रेवाइन लैंड है वो 8 डिस्ट्रिक्ट में करीबन आती है, जिसमें करीबन 800 ग्राम पंचायत कवर होती हैं। तो उस पूरे एरिया को 3 जोन में बांटा गया, फ्रिंज एरिया, बफर जोन एंड कोर जोन। कोर जोन वो था जो चंबल से बिल्कुल अटैच था, अप टू 15 किलोमीटर तक जो था, लेकिन चूंकि नरेगा में हमें काम करना था तो हमने पहले कोर जोन को छोड़ के फ्रिंज और बफर जोन में काम करना शुरू किया, और सबसे पहले फ्रिंज एरिया को किया, जिसमें 3.57 लाख हेक्टेयर लैंड का ट्रीटमेंट प्लान किया गया था, जो चंबल रिवर की किनारे से लगभग 20 से 35 किलोमीटर दूर था। तो उसकी प्लानिंग जो की गई वो जीआईएस यूज करते हुए और जो टेक्नोलॉजी थी उनको यूज करते हुए किया गया, जिससे नरेगा में अच्छे प्रोजेक्ट्स बन जाएं। तो राजस्थान ने बेसिकली प्लान्ड वे में इस चीज को करने के लिए कोशिश की और प्लानिंग जो पार्ट है वो कुछ किए हैं। जैसे डूंगरपुर में हमने कमांड एरिया मैनेजमेंट का एक प्रोजेक्ट तैयार किया है। एक सोम कमला डैम है जिसकी पूरी की पूरी कैनाल सिस्टम ब्रीच हुआ है, उसकी रिपेयरिंग एंड मेंटेनेंस का प्रोजेक्ट लिया है। उसमें हम देख रहे हैं कि दूसरे फंड नरेगा के अलावा और कहाँ से मिल सकते हैं, उसके बाद उसको स्टार्ट किया जाएगा। ऐसे ही जो वेस्टर्न राजस्थान है उसमें जोधपुर में सैंड ड्यून स्टेबलाइजेशन के प्रोजेक्ट्स तैयार किए गए हैं। रिवर रिजुनेशन का भी एक प्रोजेक्ट लिया है, उसकी भी प्लानिंग हो चुकी है, उसको भी आगे फर्दर किया जाएगा। ये सारे के सारे डॉक्यूमेंट्स किए गए हैं और ये हमने ऑनलाइन भी अवेलेबल हैं। और मैनेजमेंट और प्लानिंग के लिए जो ई मैप एप्लीकेशन तैयार की गई है उससे हम केवल प्लानिंग ही नहीं कर रहे, क्वालिटी इंस्पेक्शन को भी उसमें बढ़ावा दे रहे हैं। तो हम कोशिश कर रहे हैं कि राजस्थान में ड्यूरेबल असेट्स क्रिएशन हो, और जिससे नरेगा का जो ऑब्जेक्ट है कि ड्यूरेबल असेट क्रिएशन और क्वालिटी इंप्रूवमेंट हो, इस पर फोकस कर रहे हैं। एमओआरडी की तरफ से अभी जो जलदूत ऐप लॉन्च किया गया है।
Sorry to interrupt you, but we're running short of time, so I'll request you to please wrap up.
यस मैम। जलदूत ऐप जो है वो काफी कुछ अब ये इवोल्यूशन में काम देगा कि प्रोजेक्ट्स जो किए जा रहे हैं उनसे उस एरिया में वाटर लेवल का क्या इंक्रीजिंग या क्या संभावना क्रिएट हो रही है। तो ये भी एक अच्छा प्रयास है भारत सरकार के द्वारा जलदूत ऐप का, जिससे फील्ड में लोगों को भी जानकारी रहेगी कि उनके इस प्रोजेक्ट से उनको क्या बेनिफिट्स हुए। तो थैंक्स ऑल ऑफ यू। लेकिन मेरी अपेक्षा ये रहेगी कि प्लानिंग के साथ साथ अगर कैपेसिटी बिल्डिंग और मॉनिटरिंग एंड इवोल्यूशन के लिए भी कोई सपोर्ट्स एक्स्ट्रा मिल सकते हो तो ये नरेगा को इम्प्लीमेंट करने में और बेहतर रिजल्ट्स देंगे। थैंक्स ऑल ऑफ यू।
Thank you so much, sir, and thank you for joining us virtually. So the next presentation here we have Miss Anjali Joshi, scientist at Forest Research Institute, Jodhpur. She will be presenting on effect of climate change on crop production and its mitigation with regards to development of climate resilient varieties with special reference to rain-fed agriculture.
A very good afternoon to all. Am I audible? Hello.
Hello.
Am I audible?
Hi, Dr. Anjali. We just wanted to check if your mic is working. Can you hear us?
Yeah, I can hear you. Can you hear me?
Yeah, I think there's some. Can we increase the noise, like the volume? Ma'am, we request you to please switch on the camera. We have our guest speakers and a chair sitting right in front of us, and we can see you. So please switch on your camera.
Yeah, actually, I will be happy to do that, but you know, my networks are not proper here. I'm traveling, so it will be like it will not be possible for me, you know, to remain connected.
No issues, ma'am. And I just wanted to inform you, you will have only 8 minutes to present this. We are really running out of time. So request you to please stick to the time limit. It's 8 minutes. Thank you so much.
Okay, thank you. So a very good afternoon to all. I'm Dr. Anjali Joshi. Can I see my presentation or shall I share it from here?
Ma'am, you can share your screen.
Okay, okay.
Ma'am, your screen is
Is it
visible.
visible? Okay.
Yes, ma'am.
Okay. So a very good afternoon to all. I am Dr. Anjali Joshi from Arid Forest Research Institute, and I will speak on the topic, the effect of climate change on crop production and its mitigation with regards to development of climate resilient varieties with spatial reference to rain-fed agriculture. So first of all, we'll start with the classification of water. As we all know that water is a very important resource, especially for the survival of life on Earth. And on the basis of availability of water, it has been classified into two categories, that is the blue water and green water. The blue water, which is mainly the water which is found in the water bodies such as the lake, rivers, or reservoir, and it is one of the main source of water for irrigated agriculture. That is, it is mainly used for the irrigation of the crops. And then there is green water, which is the water that is received by the soil in the form of infiltrating rainfall, and therefore it is a sole source of water which is being used by the crops which are being grown in rain-fed agriculture. And therefore in rain-fed condition, it is the main source of water which is required to grow up the crop. Uh, then the rain-fed agriculture in India. The rain-fed agriculture is one of the most important component of the agriculture in India, and it occupies about 50.9%. That is more than half of the country's net sown area, and about 40% of the total food grain production comes from the rain-fed area in India. And the rain-fed agriculture is basically referred to the cultivation of crop without providing any supplementary irrigation, in which the crop water is the water requirement of the crop is basically fulfilled with the rainfall that is received by the area. This alongside the slide, we can see the graph that shows how the percentage of rain-fed and irrigated area in the country has changed since 2001 to 2020. And we can see that with the development of irrigation infrastructure in the country, the irrigated area is increasing and the rain-fed area is decreasing with the passage of time. However, it has been conceptualized that even if the full irrigation potential of the country is realized, still the 50% of the net sown area will remain under the rain-fed condition. That is, it is only possible even with the full like utilization of the irrigation practices, only 50% of the net sown area can be irrigated in the country, and the rest 50% will still remain rain-fed. So this concept highlights the importance of rain-fed agriculture in the country and the need to solve the problems of rain-dependent agriculture so as to maintain the production in the region, especially in India. So in order to maintain the sustainability of rain-fed agriculture, it is important to look at the climate change which is affecting the country. As far as the climate change is concerned, in temperature to the tune of around 1 degree Celsius has been seen since the pre-industrial era. And in India also the climate change has been significant, and there have been an increase of about 0.7 degrees Celsius temperature between the year 1901 to 2018, and the temperature is expected to rise further with the passage of time. So increase in temperature have also led to the increase in heat stress, as well as the occurrence of extreme weather events have increased in the recent past. Like we have seen the occurrence of a number of natural calamities, like extremes of rainfall in certain area, droughts in the other. So with the passage of time, the extreme events have been increasing. And it has been found that in India, within the last few years, the frequency of extreme rainfall events have increased, and the moderate rainfall or the normal rainfall events have decreased with the passage of time. That shows the significant impact of climate change, which is being seen in form of the rainfall events that is being received by the country. So as the rain-fed agriculture is mainly dependent on the water provided by the monsoons in India, the occurrence of extreme rainfall events have severely impacted the crop production as well as the yield of the major rain-fed crops in the countries. And this shows the rainfall trend in India from 2001 to 2020. When we have a look at the rainfall trend of the country from 2001 to 2020, we see that a minimum annual rainfall of 908.1 mm was received in the year 2002 within the last 20 years, and the maximum rainfall of 1320.91 mm was received in the year 2019. And the country received below normal rainfall in the year 2001, 2002, 2003, 4, 5, 7, 8, 9, 11, 12, 14, and 18, while normal rainfall above normal rainfall was received during the year 2006, 10, 13, 19, 20, with the normal rainfall being 1160.1 mm in the country. We see a significant number of years having either high rainfall or low rainfall. This slide shows the variation in area production of the major rain-fed crops, namely sorghum, millets, maize, chickpea, pigeon pea, groundnut, rapeseed, soybean, sunflower from the year 2001 to 2020. So these are the major rain-fed crop and the variation in their area production. And here we see the variation in the productivity of these rain-fed crop with these years. And we can see that with respect to area, a decreasing trend is seen for sorghum, millet, groundnut, and sunflower, while an increasing trend is being seen for maize, chickpea, pigeon pea, rapeseed, and soybean. When the production is concerned, an increasing trend is seen in case of millets, maize, chickpea, pigeon pea, groundnut, rapeseed, and soybean, while a decreasing trend is seen in case of sorghum and sunflower. Then this shows a variation in productivity with time of the major rain-fed crop, and we can see that there is an increasing trend in sorghum, millets, maize, chickpea, pigeon pea, groundnut, rapeseed, and sunflower, while for soybean, a decreasing trend is being observed. So this also shows that with the passage of time, as the climate is as the climate is changing continuously, the production as well as the productivity of the crop is also changing. And then this shows the correlation between rainfall and production of different crops. And all of the crop were either positively or negatively associated with rainfall. The crop production was either positively or negatively associated with the rainfall received by the area. And the association between rainfall and production of maize, rapeseed, and soybean were found to be significant. So it is very clear that the rainfall variation is like seen over the years, and an upward trend in annual rainfall is observed from 2001 to 2020 in the analysis which we have carried out. However, the conclusion could have been more precise because we have used the annual rainfall of the country, and the conclusion which we have derived could have been more precise had we seen the seasonal and spatial rainfall variation of the country into account. But then we have also seen that the production of the rain-fed crop have also changed over the years, and it may be due to a number of factors. There may be environmental factors, specifically the rainfall received by the area, because the majority of the crop which have been discussed here are rain-fed crop. And then the variation may also be due to the increase or decrease in area, the changing patterns of crop, and the improved agriculture practices, and they may be also due to the cultivation of high yielding climatically resilient varieties. So climate resilient varieties are an effective way to maintain the production of crop under changing climatic conditions, and they are like these are the varieties that have tolerance to extreme climatic events which have increased of late, such as drought, delayed monsoon, excessive water condition, etc. And therefore they provide a very simple, reliable, as well as a very cost effective approach to deal with the climatic variability that is seen nowadays. And for a variety to be tolerant, like the climatic resilient varieties which are being released, for them to be tolerant, and they must be able to like withstand or tolerate the adverse climatic condition. And at the same time, apart from tolerating the adverse climatic condition, they must be able to grow and produce successfully so
Sorry
as
to
to produce
interrupt
the.
you, Dr. Anjali, but we are almost running out of time. I request you
Okay.
to please wrap up.
Yeah, I just require 1 or 2 minutes. So, yeah, the varieties also need to reproduce successfully under the stress condition. So, generally, what happens is there are quantitative trait locus which are dispersed throughout the crop genome, which control these traits, the trait of reproduction as well as tolerance to adverse climatic conditions. So, it is very important to identify those quantitative trait locus which are associated with the stress tolerant trait and combine them together in a single cultivar to breed for climatic resilience in crops. And a number of varieties in the recent past have been developed in rain-fed crops to welcome the vagaries of monsoon in India using the advanced breeding approach. approaches. And this is the list of the varieties of such rain-fed crop which have been released in India. This is not an exhaustive list, but these are basically released for like rain-fed conditions. So this shows the maize varieties which are tolerant to drought, the maize varieties which are tolerant to delayed monsoon and flooding or submergence tolerance. These are the pearl millet varieties which are tolerant to drought condition. The pearl millet varieties which are also tolerant to delayed monsoon conditions are shown. The foxtail millet varieties, finger millet, little millet, and kodo millet varieties which are tolerant to the aberrant weather condition. This is this banyan millet and sorghum varieties. The chickpea varieties, the pigeon pea varieties, both of them being an important pulse crop of India, basically grown in the rain-fed region. The rapeseed and mustard variety, the groundnut variety, an important oilseed crop which is being grown in the region, the soybean varieties, and this shows the sunflower varieties which are being grown. These are all the climatic resilient varieties which have been released in India and are being grown in the country to overcome or to tolerate the effect of climate change. So this was all from my side. Thank you for your patient hearing.
Can we have a huge round of applause for Dr. Anjali who has joined us virtually? Thank you so much, Doctor, for joining us. For the next session, we have Dr. Srinivas Bilankati, scientist, CWPRS Pune, who will be presenting on impact of climate change on water bodies. I request her to please maintain the time limit. You have approximately 8 minutes. Thank you so much.
A very good afternoon to everyone. In coming few minutes, I'll discuss about impact of climate change on water bodies and adaptation strategies. Everybody knows that the bitter truth is climate is changing. So here I have listed some of the causes which are affecting the climate change, and many of them discussed these points. And some of the points I have listed here, ecosystems are affected mainly by temperature, salinity, rainfall, moisture, and pH. Although climate change is global, the ecological impacts are often local. Every effect is reaching to us. So the quick actions required to keep the temperature rise to minimum is extremely important for humans and wildlife. So how much difference do you think a 0.5 degree increase in global temperature can make? So here I have listed two examples like droughts. When it comes to droughts, that when temperature 1.5 degree, nearly 350 million people will be affected by 2100. When it reaches to 2 degree temperature, nearly 410 million people will be affected. When it comes to rise in sea level, 1.5 degree, 48 centimeter will be sea level. When it comes to 2 degree, 56 centimeters will be sea level increases. And million people affected also will increase, 46 million when at 1.5 degree and 49 million at 2 degree temperatures. This much difference is there just 0.5 degree temperature rise. Here I have listed the greenhouse gas effect pictorial representation. CO2 and methane are major greenhouse gases. Especially methane is nearly 80% higher rate for creating the climate change. This is the latest report from the sixth assessment report from the IPCC. The global net anthropogenic emissions have continued to rise across all major groups of greenhouse gases. So especially from CO2 from fossil fuel industries increased nearly 64%. Here, impact of climate change and water bodies. Water is a crucial enabler for adaptation and resilience. However, while discussing climate change, water frequently ignored. We discuss agriculture, forest, and energy without recognizing the critical links between the production of water, food, ecosystem, and energy. Impacts of climate change itself listed here like change in precipitation pattern, higher temperatures, sea level rise. And those consequences will also affect on drinking water, agriculture, and urban areas, energy competition for water resources. And they also affect on surface water and groundwater resources, and then geographical and pedagogical characteristics. The left side I have showed here conceptual framework of climate impacts on source water quality. The outer shell which I have showed climate exposure, the inner shell is climate hazardous, And the third layer is the water quality outcomes. If we see the sea level rise and coastal storm, while sea level rise, salt water intrusion will be increased, and consequently that will increase the groundwater salinity. Likewise, all the consequences I have listed here. When it comes to adaptation strategies to overcome the problems listed above, adaptation means like there are three major points like understanding the problem, plan to act for the problem, and the managing the problem to solve the issues. Here listed four adaptation strategies in that one sun, one world, one grid. To harvest the solar energy for 24/7, not just a day, not just a daytime, we have to connect the whole world. The primary goal of this program is to connect solar energy sources worldwide, including disposal systems like solar rooftop systems. This will successfully move towards the inexpensive renewable energy sources, thereby reducing the conventional reliance on coal. This is our main goal. Like we have to reduce the dependence on the coal. For that, we have to use solar energy or renewable energy sources. And second one is decarbonizing the built environment. For that, we have to depend on green building systems and green building materials and green building sites, so that we can reduce the greenhouse gas emissions. The third one is oceans as carbon sinks. Here, according to IPCC, the fossil fuels and industries were responsible for 89% of world CO2 emissions. For that, oceans also act as a sinks. Like atmospheric CO2 will be dissolved in the seas, and by using photoplankton through photosynthesis produce organic matter. The organic matter will be dissolved, the carbonate and sediment deposit as a sediment. Another one is zero liquid discharge. In the search of effective wastewater treatment approaches, ZLD method gathered attention. The strategic wastewater method, which does not release any liquid into surface water, effectively eradicating all associated environmental pollutants. In addition to this, ZLD process effectively use wastewater treatment for recycling and reuse, which help the water conservation by reducing the need for fresh water. And there exist many case studies in India as well. These are the highlights I have listed for the recent COP26 Glasgow Summit 2021. These 5 points were discussed: mitigation, adaptation, loss and damage, finance, and carbon trading and carbon credit. For that, this is the Panchamrit, which is presented by India's climate action, presented by our Modi ji. So India will achieve carbon neutrality, carbon net zero by 2070, and carbon intensity reduction by 40% by 2030, and carbon emission by 1 billion tons by 2030, and it will meet 50% of its energy requirement by renewable energy by 2030, and non-fuel capacity also will be increased 500 gigawatt by 2030. Based on the reports from IPCC, Kyoto Protocol, UN Sustainable Goals, we have to propose like promoting energy efficiency, promoting renewable energy, and protecting and enhancing the sinks, and promoting sustainable form of agriculture. We have to focus on these points. And in order to meet climate goals, the decarbonizing the built environment also one of the important point. And the degrees, ascertain the degrees to which the local water resources are vulnerable to the climate change, and then prioritize. We have to prioritize adaptation measures by identifying the main risk associated with them. Access the effectiveness of different coping mechanism or adaptation methods that could lessen the vulnerability of the local water resources. The three major things I have listed here: for the mitigation fossil fuel usage, for the clean and green environment, we have to adapt. We have to adapt to the climate impacts. Not only mitigation, adaptation also more equally important to the mitigation. So adapting to the climate impacts, and we have to cutting emissions and create awareness also important one, and assessment, proper assessment and financing for research and development. And then thank you.
Thank you so much, sir. Now I invite Shri Vidhi Royana, CEO, FAMS Design Solution Private Limited, will be speaking on framework of methodology and for impact of climate change and adaptation strategies for a river basin. Can we have a huge round of applause, please?
Good afternoon, all. Myself, Virad Luliana. I have started my startup 2 years back regarding FAMS. It's called Forecasting Analytics Modeling and Simulation. So based on my PhD experience since last 10 years in the water and climate sector, we have started working on this particular project. So first, I would like to discuss the challenges that water security, water scarcity, flash flood, and unequal distribution of water. For that, we need to understand first the basic studies required and for the policy making. We have done extensive analysis for Tapi River Basin, Maharashtra and Gujarat for climate variability and flood risk assessment, as well as for Mexico, Spain, and Australia in last 2 years. After the study, we find out that there are two types of risk. One is to identify the physical climate risk. One is acute, and it will be very short term. And what are the parameters we need to identify that we have identified, and which type of database we have to use to accommodate the adaptation strategies. And another is chronic risk we need to identify, and that is the hazard and risk is like drought, low and high river flow, and then change in soil moisture. This will is long-term strategic adaptation strategy we need to make based on the study. The first study we have done 3 years back regarding the Tapi River Basin using the IMD data for last 70 years, and in which we have find out that there are the total precipitation is increasing while the total number of rainy days is decreasing. Here we can Here we can see the RD values are decreasing, and number of one-day maximum rainfall is increasing. So these are the statistical indicators from the WMO standards indicators are there, and consecutive rainy days are increasing while consecutive wet days are decreasing in the basin. So this will give the scenario to plan the irrigation scheduling, then water harvesting structures, how we can integrate the climate adaptation policy. Another study we have done using IMD data that we have mapped out the aridity index based on the last 100 years data, and we found that the middle portion of Tapi River Basin, it is mainly Jalgaon, then Dhule. These are the districts involved, Akola, Amravati, Buldana. It is earlier, 30, 40 years back, it was a mid-dry, but now in last 30 years, it will come to into semi-arid. And that same trend we have find out by correlating with the stream flow analysis. So this analysis shows, if you see in 1981, in middle portion, there is a water scarcity indicator, while if we see in 2011 to 2012, the absolute water scarcity is increasing in this region. This shows that in this particular region, there is agricultural land, about 65 to 70% agricultural land, while there is a significant amount of land use changes are occurring. As we see in that graph, that deciduous forest in last 40 years, it is continuously decreasing, while the agricultural land is increasing, as well as water bodies are also increasing. So new schemes developments are ongoing in the basin. Then urban area is also increasing. So total water requirement is increasing from the in the basin. Then similar kind of analysis right now we are doing, and one of the research we have published in Springer book that in Tapi to Dadri catchment, it is a Konkan region in which nearby the coastal region the trend of rainfall is increasing, while away from the coastal region trend is decreasing. Excuse me. Currently, we are doing one of the study with the Maharashtra Water Resources Department for Krishna Basin. Here you can see, here you can see the climate variability is increasing nearby the hilly region, while total rainfall as well as one-day maximum rainfall. Subsequently, we can see here that there are 45 reservoirs are located. So we need to alter the trend of rainfall is increasing in last 40 years. And also we have to revise the policy like reservoir operation schedule for this particular reservoirs so that mitigation of downstream floods can be regulated. And this rainfall is increasing about from the average about up to 45% of the total annual rainfall. Currently, we are mapping the entire infrastructure assets of reservoirs available in the basin, and we are currently doing such kind of study like rainfall and frequency analysis based on the historical data from IMD, CWC, and state water department. Then modeling this particular asset with reservoir asset, and we are developing the integrated reservoir operation schedule for flooding. So this is one of the hydrological and hydraulic modeling study we are adopting for flood and discharge computation along the Krishna River. And these are the key locations where the flood inundation are happening, we have identified. Another study we have done 2 years back, and it was published in American Society of Civil Engineers. That is the prediction of flood stages in Surat city. So based on the red line, blue line criteria, like 25-year return period flood and 100-year return period flood. So from the UKAI releases, we have done the extensive flood frequency analysis for the Surat city, and then we have modeled through HACRES model, and we found out the critical region across the Surat city, and this report has been submitted to Surat Municipal Corporation for the levee designing along the river banks. One of the study last year we have done for infrastructure assets in Mexico, Spain, and Mexico, Spain, and Australian infrastructure site. Two sites are energy, solar power energy site, and one is warehousing site. So what we have done, the objective of the study is to identify the risk assessment for a particular infrastructure site. So what we have done first identify the location, and then based on the historical data, we have classified 2-year, 5-year, 10-year, up to 500-year return period flood for the rainfall frequency, and that has been that trend anomaly we have done across the month. So here you can see the trend variation in across the month from the Mexico slide. And then they have told us the client was the insurance company. So the client told us to identify the future trend also based on the historical assessment. So we have identified the future trend for RCP 4.5 and 8.5 scenario. And we found that in here you can see in February month, in historical data, the climate variability is large, but in future trend, it is a decreasing. It is a extreme. Yeah. So we have identified such kind of historical events for 4.5, 8.5 scenario, number of events, and then year-wise inundation, and total number of business operations are hampered during the year-wise we have calculated. So based on this, we have given the exposure and risk assessment methodology for the identification of physical infrastructure of the risk. One study we are doing sub-basin wise infrastructure risk assessment, physical risk assessment, and we have identified the sensitivity and adaptation ability to measure based on the climate change statistical indicators. Once we select the indicators, the final indicators we need to identify based on the climate change parameters like climate variability parameters, and then sensitivity and adaptation ability parameters we need to identify. Last one slide, this one. We are developing in-house development are ongoing on FAME's risk advisory platform. Based on the, we have mapped out the tehsil-wise maps and rivers and assets for across the India. And these are the indicators from WMO we are obtaining. And these are the this methodology we have developed for state and basin wise, and we are planning to identify the hazard indicators for a particular tehsil. Thank you very much for the presentation. Thank you.
Thank you so much, sir. Once again, just to keep you informed, we are organizing an Agra tour tomorrow. So whosoever is interested, please register yourself at the registration desk and you will get all the relevant details over there. So next up for the presentation on climate resilient development and water resources management, empirical learnings from the field of Indo-German bilateral project, water security and climate adaptation in rural India, we invite Ms. Radha Priya, Technical Advisor, GIZ India, and Dr. Renga Lakshmiya, Director, Ecotechnology, MSSRF. Can we have a round of applause, please? And I request ma'am to please stick to the time limit. Thank you.
One, another presentation. Another one. Two presentation. One. So, good morning, good afternoon, one and all. Next. Okay. Okay, thank you. Yeah, climate change is adversely impacting the seasonal climate and weather patterns with a sharp increase in extreme weather events leading to disruption in hydrological cycles. Between 2001 and 2018, 74% of the natural disasters were due to water, extreme heat, including droughts and floods. So according to Intra-Government Panel on Climate Change, that is IPCC 6th assessment report, emphasized that immediate climate action is required for climate crisis. So inaction of climate crisis will further deepen the climate risk to the vulnerable people and the environment. So against this backdrop, augmenting the water resource is the one of the catalytic action to improve the climate resilience. So water security and climate, based on this context, actually, water security and climate adaptation in rural areas of India is a bilateral project commissioned by the German Federal Ministry of Economic Cooperation and Development partnership with Ministry of Rural Development and Ministry of Jal Shakti. In this water security project, actually, we have implemented in 5 states. So here, actually, we are going to present about the VASCA implementation in Tamil Nadu. So in VASCA, Tamil Nadu, we work with Department of Rural Development and Panchayat Raj Department. At districts, we work with District Rural Development Authority. So already morning, actually, so many dignitaries told about this per capita availability of India. So as per the Falkenmark water stress indicator, clearly explained that when annual water supplies drop below 1,700 cubic meter per person per year, that area or that country or region is declared as a water stress region or water stress nation. So as per the Falcon water stress indicator, Tamil Nadu also, we can see that India is actually already water stressed. Actually, minimum we have to be 1,700 cubic meter per year is required. But as per the Niti Aayog 2018, 1,545 cubic meter of water is available per person per year. So India is already water stressed. From that, actually, why Tamil Nadu is chosen for VASCA implementation. So Tamil Nadu is also water stressed from 1951 to 2011, if we have seen in that. So from 4,400 cubic meter to now it is reduced in less than 600 cubic meter. So this is the Tamil Nadu states. Based on this perception, so the climate, we have to implement the VASCA project in Tamil Nadu state. We have to identify 2 districts. For identifying these 2 districts, we have done the scoping study. In the scoping study, actually, we have chosen the 18 indicators. These indicators covered 4 different sectors like socio-economic, water, climate, and agriculture. So based on this scoping study, we have analyzed the whole Tamil Nadu, all the districts actually, 18 indicators we used. From this actually, more vulnerable districts were chosen for this water security and climate adaptation project implementation, in which actually 4 vulnerable districts were we have identified. First one is Ramanathapuram and Dharmaburi, third one is Perambalur, fourth one is Tiruvannamalai. So based on the state government suggestions, we have implemented VASCA project in Ramanathapuram and Tiruvannamalai district. So why Ramanathapuram and Tiruvannamalai means actually based on the 18 climate indicators, the socio-economic vulnerability, if we are going to taken into the socio-economic vulnerability, the poverty index is more, and source of drinking water within the premises is also very low, and the high rural population in both the districts. And taking account into the climate vulnerability, the daytime increase in daytime temperature is high, and rainfall variability is also very high. And in water resource vulnerability, in Ramanathapuram district, actually in Tamil Nadu, the FIRCRA-wise actually groundwater analysis were done actually. In that actually the Ramanathapuram districts, so many FIRCAs are the saline and poor quality of water is identified. In Tiruvannamalai district actually 52 FIRCAs were there, almost all FIRCAs were not in safe condition. So these 2 districts were identified for the VASCA implementation. So these are all the indicator dimensions for this Ramanathapuram and Tiruvannamalai. So other than these 18 indicators, the future projections of the Ramanathapuram in Tiruvannamalai also is also impacting the more into the two districts. Baseline data of 2010. IMD data has taken, and based on this baseline data, we have projected for 2020 and 2050 and 2080. The minimum temperature is increasing 1.1 degrees Celsius for 2020, and 2050 it will be 2.1 degrees Celsius, and 2080 it is 3.2 degrees Celsius. And the maximum temperature is actually 1.10 degrees Celsius in 2020 and 2.40 degrees Celsius in 2050 and 2.7 degrees Celsius in 2080. So the rainfall range is actually from baseline of 2010, if we compare 2020, actually 2% rainfall was reduced, and 2050, 5% rainfall will be reduced, and 2080, 4% of rainfall will be reduced. So next we will take into the Ramanathapuram district. Ramanathapuram is a coastal district. Sea level rise is the major problem. Also, this climate impact, maximum temperature is also increasing from 0.89 degrees Celsius to 1.2 degrees Celsius at 2020, and 2080 it is increasing 2.71 degrees Celsius into 3.73 degrees Celsius. Likewise, the minimum temperature also showing the same condition. So the temperature is going to increase up to 3.23 degrees Celsius into 2080. So the rainfall detail actually, yeah, Ramanathapuram district is going to receive 1% rainfall is maximum during the 2080 projections. So the implementing this VASCA project, so we have followed the, so we have considered this following the informations. Actually, for key approaches for water security and climate adaptation, first we have followed the evidence-based scientific approach and rich to valley approach. Third one is land use-based solutions, And fourth one is promoting locally led climate adaptation measures. And fifth one is building the assets of vulnerable and marginalized to adopt the climate change impacts. And sixth one is community-based adaptation by engaging people. So first one, for evidence-based scientific approach, we have used a composite water resource management plan. In this composite water resource management plan, first we have analyzed the water budget of that particular village. And based on the water budget, we have identified the key issues. Then we have proposed the key water actions to the village. So based on this CWRMP, we have different categories. One is public and common land activities, and development of agriculture and allied land activities, and development of rural infrastructure. Fourth one is development of climate resilient measures. So in CWRMP, we have composite water resource management plan in 4 different sectors. We have used these parameters for the analysis. So based on the CWRMP, both the districts, totally actually 1,229 Gram Panchayat were there. In that 1,229 Panchayat, we have identified this number of CWRMP. Through CWRMP, we have identified 2,28,000 works, and Ramanathapuram, we have identified 2,30,000 works. So the next one is the total non-NRM works and NRM works are also entered in D29 MIS portal. And number of works also they are started to implemented in both the districts. So I told that the public common land, yes, public and common land development, actually we have used continuous contours. Already actually morning, there's so many dignitaries are explained about the various MG Narega works. So those works only we have splitted into these 3 categories. So these are all the works we implemented, and some of the works are ongoing. So the climate resilient measures, based on the climate hazards, we have proposed climate resilient measures, cascade of tanks, farm ponds, and various plantation activities, greening of hillocks, spring shade, fallow land development. These are the works which we proposed. And these are all the 2020 and 2025. We have proposed a 5 years perspective plan for Tiruvannamalai district for all the categories. The cascading of tanks, actually we have given the DPR to the districts, and the works are started. And these are all the farm ponds. The 121 farm ponds are implemented within 30 days. They received Elite World Record, Asian records, and India records, and Tamil Nadu records, Tamilan records. And we have actually most of the MG Narega plantation activities are depending on the nurseries only. Once the people are getting plants from forest or other than outside, actually the cost will be high. So the MG Narega itself, they have developed 31 block nurseries, 5 district nursery, and even Gram Panchayat also they have developed the nurseries. And these are all the greening of hillocks. So 21 sites were identified, and the implementation sites here we are seeing. And these are all the honey pots and silvipasture sites. So the silvipasture sites, actually the Tamil Nadu issued order for the replication statewide, and greening of hillocks and farm pond also they have given the replications. And this is the Ramanathapuram, the perspective plan for 2025. These are all some of the climate resilient measures. Actually, we have implemented Tanka in Ramanathapuram districts. The Ramanathapuram technical people are visited to Rajasthan. So due to the exposure visit, the learning from Rajasthan, the traditional Tanka is implemented in Tamil Nadu too for climate adaptation measures. These are all the mini forests. 1,000 mini forests were developed during VASCA project, and 120 mega forests were also implemented. And these are all the various climate thematic parks. Thank you. Now over to Dr. Rengalakshmi, madam. Debashree.
Afternoon, everyone. In continuation of our VASCA experience in Tamil Nadu, in both the districts. Now we are in the process of upscaling the whole initiative at the state level. For that, we have developed some of the tools which help in the upscaling process. I'm just skipping the initial slides. So we implemented the activities in 1,289 GPs, and now we are in the upscaling process. In the upscaling process, we have developed 3 tools. One, basically a kind of an assessment tool, vulnerability assessment. And the initial period, we did the district level assessment. Now using the data sets, we are going for village level vulnerability assessment. Then planning tool, then evaluation tool. But now I'm going to explain only the planning tool, how we did and how we are going to take it forward. And this planning tool consists of 4 major sections. The first section about the SCWA. SCWA is basically socioeconomic, climate, water, and agriculture vulnerability in the particular GP. Then it is combined with groundwater assessment, because in the earlier CWRM tool, the groundwater was not given much attention. But now, considering the issues which is cropping up in the state, we have included groundwater assessment exclusively within the CWRM work. Then the suitable locations are being identified using mobile app. The verification are being done, and again it linked with D29 process of MGNREGS. So this process help the planners to reduce the time and increase the efficiency. So this is a kind of the outline of the tool, which is available in that particular link. Maybe later I can share the link for further fine tuning according to their own situations. This is the mobile app for verification. After verification, it is directly going to D29 process. That way we can reduce the time and increase the area of work. So the tool, it has a kind of a functional value for different users. For at the user level, it helps to identify the shelf of projects, because the shelf of projects plays a major role in bringing the climate angle into the planning process. And second one is at the practice level, it supports the GP and block level officials to bring the scientific approach into the planning and implement. And also it is a dynamic one, so every year you can revisit and improve based on the progress which you have or challenges you face during the process. And third one, at the policy level, it supports the better decision making and monitoring at the district as well as the state level. And again, the tool can be useful for private sector research institute, NGOs who are involved in many pilot models in the district. So concluding, it is a kind of an adaptation-based indicators in the analysis at the GP level, that is one. And second, it is a large amount of data, that is the big data, which we can handle effectively using the IT tools, both for vulnerability assessment, planning, as well as monitoring the whole event. That is the evaluation, how the indicators are impacting the climate risk at different levels. And it is again interlinked with 2 of the major schemes, but other convergence schemes can also be promoted at the district level or block level, even at the village level also. So with that, we are concluding. Thank you so much.
Thank you. Thank you so much, ma'am. So just to update you guys, we are running 1.5 hours late, and we have our next session at 2:30. So I request, it's a humble request to all the presenters and speakers to please maintain the time limit. Next up, we have Dr. Arvind Kumar, IVF President, Delhi, on climate change adaptation via cross-cutting methods. I request him to please come up on the stage.
Next, okay. This one. Good afternoon, everybody. So The topic is climate change and adaptation by cross-cutting routes. Next. This one. Okay. Yeah. The objective of this presentation is to understand how climate change is aggravated by unsustainable practices in different sectors like water, agriculture, etc. How timely adaptation practices like ecosystem adaptation, EBA, as a strategy will not be only transform economies but also addresses climate change impacts. Tangible efforts of climate change are already being experienced around the world. Changes as a result of the globally raising average temperature, increase frequently and intensity of extreme weather events, like heat waves, South Asia and Europe experienced this year, drought, storms, territorial rains and floods. These changes and events are interlinked by various ecological and social economic relationships, and interconnected systems are often referred to as a transnational efforts or transnational dependencies. So this is the fourth slide. To limit us as a 1.5 degrees centigrade target is not some random strategies and statistics are there, but rather an indicator of the point at which climate change impact will become increasingly harmful for us and our planet. We need large-scale transformations to achieve the goals such as major shift in technology costs, attracting more climate finance and investment from developing countries as promised, building an action by non-stakeholder actors like civil societies and private sectors, exploring synergies among various SDGs, because it is like a chain reaction. You cannot achieve one SDG by neglecting other. Building participation of diverse stakeholders like national and international agencies, UN governments, women, youth, NGOs. Bolstering implementation of commitments and continuing pushing for them, aligning all our actions with carbon neutrality. So the challenge of climate change, however, are systematic and wide-ranging. These are the compounding effect of multiple and interacting drivers such as mentioned in the slides. This one. Rising number of extreme weather events like floods, droughts, storms have costly impacts on cities, basic services, infrastructure, housing, human livelihoods, and health. Changes in various natural cycles such as water, carbon has affected the process of food production, and people depend on natural resources and agriculture for their livelihood. Disrupting weather patterns leading to extreme weather events, unpredictable water availability, aggravating water scarcity, and contaminating water supplies. Extreme events related to climate change are putting pressure on natural ecosystems and therefore threaten biodiversity and have implications for food security too. Due to intrinsic uncertainty in the climate projections and its related effects, the diverse and rapidly climate nature of the community vulnerability and the random nature of the individual extreme events are increasingly. Melting glaciers add to rising sea levels are increasing cost erosion and elevating storm surge, water, food insecurity, etc. We should adapt ourselves to meet all possible developments as a matter of principle. Therefore, more ambition is needed, such as integrating ecosystem-based adaptation approach in state and national policies, as I actually observe in different other presentation as well. So knowledge-based adaptation and governance, enhancing climate resilience of communities, integrated mitigation and adaptation approach for a global transition to a low emission economy and a resilient world. Actions that promote both goals provide win-win situations. At the risk of repeating myself, I would reiterate the multi-stakeholder involvement in imperative to achieve these goals. Due to population births and to feed more mouths when more land is being used for agriculture, forests are being raised, and we are witnessing the consequences. So we have to transform social forestry into economic forestry, like we did in Meghalaya. I will mention in the next slide. Here, I would cite the example of Meghalaya, where as a knowledge partner and implementing partner, we facilitated center-state convergence, supported public-public partnership, elicited cooperation and expertise from national, international development and funding agencies. Almost 17 development partners were working in Meghalaya, including funding partner, technological partner, UN, and other. And designed and implement program to sensitize the community and compile global and local knowledge and learning to further disseminate in the masses. Meghalaya economic clauses try to natural resource based and climate sensitive sectors such as agriculture, water, forestry. We understood these problems at a closer level and came into conclusion that piecemeal approaches to water, energy, or biodiversity resulted into sectoral solutions and seriously lacked cross-cutting overcomes with its interconnected sectors. So this is the mantra of the Integrated Basin Development Livelihood Mission. It's designed 4-pillar knowledge management, natural resource management, and entrepreneurship development. The good governance, and especially the commitment in good governance, is being implemented in a mission mode through over 2 dozen missions. Every mission is designed to leverage the comparative advantage that Meghalaya has and generate livelihood opportunities for every household and to accelerate growth. The basic strategies resolve around enhancing development from periphery to mainstream through an area-wise basin approach rather than department-centric approach. It addresses crucial links between climate change, biodiversity, ecosystem services, sustainable resources management, linkage between water, human development, and impacts of people, lives and livelihoods, derives environmental benefits towards holistic ecosystem services. Next. So our key inputs resulted in creating alternative livelihoods for narrative community, which are successfully in addressing unemployment, unsustainable mining, migration, reducing poverty, gender disparity, enhanced socio-economic environmental indicator of the state. So this is my latest book. Everything is actually on ecosystem-based adaptation delivers on these approaches and affirm that water is the most effective tool to tackle vagaries of climate change. Because climate change is a water change, water should be an integral part of the initiative to mitigate and adapt to climate change in the wake of the fact that the impact of climate change are felt through water, and it become a critical factor for successful climate change mitigation. As an effect to reduce greenhouse emission depend on the reliable access to water resource. The conclusion, holistic thinking, cross-sectoral perspectives and proactive works are required to advance climate adaptive works. We have to focus on cross-cutting challenges which include geographical boundaries within the between countries as well as administrative boundaries between various actors, diversification, partnerships, integrating mitigations and adaptation and a flexible institutional interface should be worked on. It is imperative that actor and across sector must systematically integrate water resources management into their climate adaptation and mitigation strategies. We should remember that nature is our ally and must not be forgotten in initiating development program, because it is just not provided for society's need via ecosystem services, but protection from disaster as well. Thank you very much for your time.
Thank you so much, sir, for keeping it short and crisp, and congratulations on your new publication. So I now request Mr. Joshlal K. Bansal, JRF IIT Roorkee, to please come up on the stage to speak upon calculation of climate indices using CMI P6 climate data over Rajasthan state of India. Also, we request everyone, all the guests and speakers, to please collect your bags from the registration desk. Thank you so much.
Good afternoon all. Here I present my topic on calculation of climate indices using CMIP6 climate data over Rajasthan state. So basically, I would like to introduce what is climate indices. Climate indices are basically the monitoring tool that has been designed by ETCDDI and WMO to calculate the climate scenarios and its effects on a particular area or anywhere. So basically, my main objective is to processing of GCM data of CMIP6 based climate models and generation of climate indices like dry days, wet days, and SPIs, etc. The two kind of models that I have used are assess ESM15 and ESM-R3, which is a 25-kilometer resolution. Basically, this data is downloaded from Zenodo website. It is a bias-corrected data available by Vimal Mishra, IIT Gandhinagar. It is a freely available data. Anyone can download it. So basically, what the methodology that I have used is that I have downloaded the data and created three scenarios. One is historical, and then there are other two future scenarios, SSP245 and SSP585, which were further divided into two parts. One is the near-term scenarios, one is 2020-2050, and then other is 2060-2090. After that, the indices are calculated using XClim library in Python. It is basically a dedicated library for climate indices. So these are the results. Basically, this is a very small part of the work that I am doing. So basically, here I'm presenting dry days, wet days, and SPIs for Rajasthan state. As you can see, actually there are total of 500 grids that we have calculated on, but here I'm presenting only the 11 grids. So basically, you can see that in several grids there is a increase in dry days, and in some other grids there is a decrease in dry days for both of the models, same as for wet days and same as for SPIs. Basically, this is because it varies from region to region, as Rajasthan is a very big region. So it varies from region to region, and it is validated with a paper published by R.K. Pradhan. He published a paper where he mentioned that in Rajasthan state, climate indices vary state to region to region. So here I conclude my presentation with saying that the number of dry days are decreasing for several regions, especially for like Ajmer region, and for wet days are increasing. And dry days are also increasing for Churu Ganganagar region. With coming up to standard precipitation index, here you can see the values are closely to zero or negative. The negative values state that there is a probability of drought, but the values that are close to zero represents there is a severity of drought, but there are some values that are more than zero, which represent there is less probability of the drought. Thank you.
Thank you so much, sir. So I now request Ms. Tanya Dwivedi, Research Scholar, Manit Bhopal, to speak on emerging water management paradigms for climate change adaptation.
Good afternoon, everyone. My name is Tanya Divedi. I'm an urban planner and currently a PhD researcher in Maulana Azad National Institute of Technology, Bhopal, in a project Water for Change, which is an Indo-Dutch research collaboration. Today, I'll be talking about emerging water management paradigms for climate change adaptation. The starting point of my presentation is a bit different from the other presentations. I want to bring your attention to multidimensionality of water. Water is just not the water that is present in this bottle. It also has a socio-cultural dimension, an economic dimension through livelihood of people, a spatial temporal dimension through distribution of water sources across the country. So just to keep that in mind, water is intricately linked with life and livelihood of the people. And with climate change, the instances of water extremes are increasing in frequency as well as severity. And the speciality of these water extremes, due to that, there is too little water somewhere, whereas some areas are being inundated by flash floods. According to some estimates, around 152 to 422 million people in urban India are facing water scarcity. And of that, 30 to 50% of this water scarcity is actually driven by climate change. Climate change, which is the climate change impact that is manifested through water, also impacts human health, agriculture. There are conflicts which are driven by water. It can also cause migration. So, these climate change impacts are disproportionately being borne by the vulnerable sections of the society, especially the urban poor. The conventional approach of water management in India and other countries has been such that it fails to acknowledge that water is a holistic cycle. It should not be looked in silos. For example, for water management, we have different departments looking at one aspect of water like supply, the second of sewerage, for drainage. But in the end, the water does not follow these silos. It is a holistic cycle, and we need to acknowledge that. Better management of water resources is thus very crucial for mitigating the impacts of climate change. There should be evidence-driven institutional reshaping and strengthening. And most importantly, which is also the theme of this conference, that acknowledgement of equity issues, especially in access to water, has to be looked into. In India, water management presents a very unique challenge because of the diversity of water available in the country. There is diversity in climatic, physical, spatial, ecological, social characteristics of water resources. And there is one water policy that is governing, which is the National Water Policy. It raises issues of water stress across the country, which is negatively affected by climate change. It also talks about urbanization and changing lifestyles of people. It tries to cover the holistic nature of water by including concepts of water governance and management, disaster management, etc. Water policy, national water policy calls for preparation of national plan, which should be translated into state action plans, and some of the states have already done that. So my presentation focuses mostly on how to go about this water management, what should be the guiding factors. Some of the paradigms of water development, they started from the late 19th century, when the water services, as we know of them today, were non-existent. So it brought about a very big change in infrastructure, which is called the modern infrastructure ideal. Big pipelines and big treatment plants were established. However, it was soon realized by the 1980s that this is a very fragmented way of looking at water resources, and a new paradigm of integrated water resource management came into picture. Integrated water resource management is a process which promotes the coordinated development and management of water, land, and related resources in order to maximize the resultant economic and social welfare in an equitable manner without compromising the sustainability of water ecosystem. So if we can see, IWRM has three basic pillars, which is social equity, environmental sustainability, and economic efficiency. However, because this is a very broad concept, it had a very malleable language, which led to some of the loopholes and varying interpretations. It was found to be superficially democratic. And there was precedence given to technical knowledge than other forms of knowledge, which also includes the local or traditional knowledge. So in reality, if we see IWRM mostly focused on economic efficiency, maintaining and promoting the economic efficiency of water rather than looking at social equity and environmental sustainability. Coming back to the paradigms, these paradigms are being seen in the context of growing up pressures on urban water system, which include climate change, growing demand and urbanization, aged infrastructure, depleted and polluted resources, increased frequency of disrupted events. So after IWRM, even though it is being followed in many parts of the world, even in India, after IWRM focus of the paradigm development, it shifted to an urban area. So integrated urban water management, the paradigm came into picture because it was felt that the concerns of the urban area were very different from the regional areas. After in the late 1990s, it was seen that because climate change impacts were happening more frequently, it was seen that water systems are very vulnerable to climate and anthropogenic changes and shocks and uncertainty. So a new paradigm of water-sensitive urban design came into picture. It focused more on the built form in the cities. However, it was seen that it still did not acknowledge the holistic nature of water system. So a new paradigm came in the late 2000s, which is the water-sensitive cities. It takes into account that water systems are vulnerable and solutions cannot be disassociated with the academic sector. So water-sensitive cities, this paradigm talks about, it takes the approach of previous paradigms. 2 minutes, okay. Okay, so water sensitive cities builds upon 3 basic pillars. The first is that cities have to act as catchments. Whatever water falls within the city, they have to use it either by rainwater harvesting, either by reuse or doing recharge. The second is that cities should provide ecosystem services. To enable cities to act as catchment, the infrastructure, for example, green bodies, green areas, pervious surfaces, that has to be provided by the city. And third, which is, I think, the most important of all, the city should house water-sensitive communities. The people should be sensitive enough to water sensitivity. Water-sensitive city paradigm is rooted in local context and takes into account the key social and institutional conditions which are there locally. So I'll just wrap up by saying that to operationalize water-sensitive cities, we have to have systems thinking, interdisciplinary thinking, design thinking, and collaborative thinking. And we have to somehow merge the water system with urban and social fabric through channelizing investments, technological breakthroughs, participation platforms. Even though most of our cities are right now water supply city or just seaward cities, we can move towards water-sensitive city. It is not a stage-wise process. It is a spectrum, a transition spectrum, and we can leapfrog to those cities. I'll conclude by saying that our cities are ill-equipped in terms of infrastructure as well as institutional framework. So vulnerable sections of the society are disproportionately affected by climate change impacts. Sustainable water management with focus on justice and efficiency may cushion climate change impacts in water and safeguard the communities. Leapfrogging from current state of water management to a water-sensitive city may reduce climate change impacts borne by communities and environment. Water-sensitive cities act as catchment for its water needs, have necessary infrastructure for ecological conservation, and is home to water-sensitive communities. So implementation of water-sensitive cities entails institutional reforms, infrastructure overhaul, as well as behavioral change. Thank you for your time.
Thank you so much, and thank you to all the presenters, speakers who were here and gave us an insightful session. Moving forward, we have a panel discussion. So I request our moderator, Mr. Rajiv Ahel, our panelists, Shri M. Gopalakrishna, Mrs. Elizabeth, Shri B.P. Yadav, Shri Sunil Kumar Arora, to please come up on the stage. Once again, I request all the guests and panelists to collect your bags from the registration desk. So we have Mr. Yogesh Kumar, Department of Rural Development, UP, with us. So I request Mr. Rajiv Ehel to please take it forward from here.
First of all, I really want to appreciate the people who are still here. Thank you very much. I know there's food and then there's food for thought, and I really appreciate you. We won't take long. And the idea is that whenever you do manthan, when you take chach and you know, swirl it around, if you don't get butter, there's no point of having done it, right? So this is the butter making session, and we'll keep it very short. I think since the morning you've heard from people time and again, reminding us what are the key problems, what are the key challenges, the scale of challenges, and the imminent doom, gloom, and the way we are headed. We also heard, as what you said as well, that it is here. Now, how do we deal with it? We also saw and heard now from various people conceptual ideas, policy perspectives. We heard from practitioners implementing at the level of states like Tamil Nadu, Uttar Pradesh, Karnataka, Rajasthan, which each by itself is bigger than a country in the world. And the scales of complexities and problems are far more than found in other countries. We also heard from very good researchers in terms of analysis, tools, approaches that are available. So I think we have quite a lot. So my suggestion or my request, and I would start with our chair here, each one of the people we have here, of course, is a domain specialist, has their own experience. But I would also request them now to become agnostic to it and only look at what we have discussed today. And from all of that, request to each one of you to maybe take 3 to 4 minutes and identify only three way forward concrete actions coming from what we know, what we've heard, what we've seen, what we believe could work, given your experiences. I'll request also the documenters to document it. So in more precise term, in each of these ideas, who should do what and how? Why we know. So who would like to take this very difficult challenge as a first go? So experience before. Would you like to come here? You could also come here, because I think that mic may not be.
Yeah, I thought of coming at the end, but you want again, I want to break the tradition of the senior coming first. He should come the last. Of all the people, I am 80, so I am senior. I have no doubt about it. Okay, no, it was a very wonderful session. I think many practical facts that came up, and as was rightly pointed out, a wide gamut of problems, identification, and possible way of approaching and solutions, successful also, they came up. Of course, we had the first few presentation, which is a sort of a report card that is trying to impress as to how we are going about in respect of several local actions for this global challenge of climate change and its impact on water bodies and livelihood, humanity, etc. More importantly, the subsequent presentations, more in scientific nature, they brought home the importance of looking forward to meaningfully orient our actions in the field. That's very important. And all of them had brought out as to what we must do as a way forward in order to combat the disastrous effects due to climate change. And in that process, we heard almost from north to south and west to east. And we touched upon what UP is doing, Rajasthan is doing, besides Karnataka and down south, impressive examples from Tamil Nadu. So I think all of them were useful. And in the process, we also could see how a sort of a cooperation can be ensured in taking our future actions. We saw that not only the academic inputs were getting into the whole process, the scientific as well as academic, but also in enterprises like M.S. Swaminathan Foundation in respect of the Tamil Nadu example, setting in to work with the governmental agencies and departments. And also we learned how there is a sort of participation, public, private, as well as other vested interests, institutions, and cooperation between those who can afford to put funds. So this is the way we can successfully probably take action to combat the climate change. The three important things which was asked to be informed, as I told, it is a global challenge, and one way is from local actions to face the global challenge. The other way is, while this bottom-up is excellent, quite desirable, when we look at the problems at macro level, that is global, then country, then state, and other levels, the other type, there has to be macro solutions in order to ensure that the future water scarcity is successfully addressed. Not only all these various actions in minor scale is going to help, but in case of successful droughts, all these things may not also work. And that's where I try to indicate, while small is beautiful, big is bountiful. So in that, planning has to be on a gross scale. And I'm sure the center is already looking into all angles where from water could be tapped. And it is one of the things in which interbasin water transfer is also being planned, and storages that could provide resilience against successive droughts would also be possible. So these are macro actions, and the other things are micro action, and they are not macro vis-a-vis the micro. Together, they all can do a lot. And more importantly, several times it sprang up, the institutional silos, as well as not taking public into confidence. So good mechanism to work it out has also emerged. And cooperation with international agencies, just as in the instant case with Germany, GTZ, this is something very desirable, and we should try to also do likewise in respect of those who seek it, be it in Africa or small island nations. So the world is large, and all of us have to do our best in order to combat the challenge. With that, I end, and I thank you for giving this session to me.
I think that really set the context for others to step forward. Mr. Sunil Kumar, would you like to come and share your three ideas?
A very, very good afternoon to all of you. I deem it a great honor and privilege to share my views as a panelist on this topic of climate change and adapting strategies on this special day of India Water Week. That also in front of such an intelligent delegates. Climate change. As you all know that climate change is a synonym to water crisis. Today I'll not go into the details of what are the causes of climate change and because of that, what is happening in the world. I'll just discuss the way forward, what we should do. So my first suggestion is that water should be the center stage of climate policy of any government, be it a state government, be it a government of India, or other governments of the different countries. And before going further, I'll take few seconds only to tell you about a National Water Mission. I am working as an advisor in National Water Mission. National Water Mission was one of the 8 missions which were set up out of the when this National Action Plan on Climate Change was set up, and it works on 5 distinctive goals. Whatever way ahead we are having for climate change, for the climate change, either we have to mitigate it or adapt it. And for both those activities, whatever is our way forward, we are working in our goals of National Water Mission. Like first of all, about water, we have to see the demand and supply, both side of the water management. If we are conserving water, if we are conserving rainwater, and we are not exploiting the groundwater, definitely our energy consumption will reduce, which we use to pump out the water. Carbon print will reduce, and definitely it will help in mitigation of climate change. Water conservation, which is also one of our goal, is one of the most important thing for mitigation of climate change. Then second aspect is water use efficiency. It means to reduce the demand of water without affecting the functional requirement of any activity. So if we are increasing our water use efficiency, that will definitely increase the supply of water, and again carbon footprint will be reduced. So for both the activities, we are working, and we should work like National Water Mission has been organizing the Jal Shakti Abhiyan, which was launched by Honorable Prime Minister on 22nd of March 2021 on World Water Day. And that this was the, you can say, one of the biggest campaign on water conservation with people's active participation. And last year, around 65,000 crore rupees of work, water-related works was done through AMG NAREG's funds only. And total more than 46 lakh of water-related structures were created. And besides that, we have asked the states and the district to create a Jal Shakti Kendra, a single point knowledge center on all the matter of water-related structures, water-related problems. And we have issued one advisory also on that, and asking comments and inputs from the stakeholders. And we request, if you are getting the advisory request, to send your comments. We will improve that advisory. This advisory, we are going to send it to the district as well as to the states. And in today's presentation, when people were giving presentation, I have noted 4 or 5 points that, like in one of the presentation, one of the address by Mr. V.M. Gopalakrishnan, he says that we have to create sufficient storage for water security. This is also one of our way ahead. We should work on this. And like today, Commissioner Rural Development, Karnataka government, she has given a very good presentation where they are doing through Jal Sanjeevani in NRM planning of works in Karnataka. And UP also is doing a good work. They have shown their interest, how much interest they are taking in water-related works. And one more new things I came to know today, that is from state of MP, that is five P's of sustainable development: people, partnership, planet, peace, and the prosperity. Earlier, we used to hear about the three R's: reduce, reuse, and recycle. So in National Water Mission, we are trying to convert it to 5 R's: reduce, reuse, recycle, then recharging of ground earth and rejuvenation of rivers. And the fifth and the foremost and the most important is respect to water. With the passage of time, we have reduced our respect to the water. We are polluting the water. We are not using the water properly. Respect does not mean that we are going to the water bodies and jalao samdiya and giving respect. Yes, that has to be done. That we used to do in the ancient days. But respect is we have not to pollute the water. We have not to misuse the water. This is the way ahead I can speak. Thank you very much. Jai Hind.
Thank you very much also to our esteemed collaboration partner for VASCA and Indo-German Development Cooperation, Sunil ji from National Water Mission. I'll now request Yogesh ji, if you'd like.
Thank you, Rajiv ji. Rather than introducing three concepts, I'll say five things. First is, because I'm an administrative, a person from administrative background, I see there is a lot of missing coordination and convergence between different departments and schemes. Until unless there is a smooth, seamless coordination between department and schemes, nothing is going to fructify. There is a lot of duplication of efforts. Like the department micro irrigation is claiming the assets of irrigation to be their own, but we are working, horticulture is claiming, but horticulture is working, agriculture is claiming of their own. There are a lot of duplication of efforts. There has to be a seamless coordination and convergence, first. Second, there is stark missing is national technical platform from which we can see what planning on what infrastructure we have to focus. What we are doing, haphazard planning. Some people are demanding for work, like in Mahatma Gandhi Narega. So we give them work. You work in the field, you work for the plantation, you work for this soak pit, for that recharge pit, a boundary wall of school, Anganwadi Kendra, Panchayat. There are more than 250 activities. There is no planning at the GP level. They plan 12 works. They are all Nali Klanja, CC road interlocking and all that. They don't plan anything which is related to livelihood activity, animal husbandry, water conservation, or soil conservation. So there has to be one national level technical platform from where Gram Panchayat will be able to take it traces. Then obligatory fund pool mechanism of different schemes. There are multiple types of schemes which are working in this area, like PMKSY, Central Finance Commission, State Finance Commission, Manrega, Campa, Irrigation, Micro Irrigation, Agriculture Funds, Forest Department, Fisheries Department. There are almost 18 to 20 departments which are investing in this sector and which are earning also, like out of the economic activity. Their funds should be compulsorily integrated and converged. Then we can produce more effective results. Seamless connection between researchers, technical institutions, and implementers, we guys. And last is remaining open to and accepting the outcomes, what has been planned and what is being implemented. Rather than going into a blame game after 5 years, 10 years, 20 years, this was planned wrong, like these people are responsible, because we generally don't take any step ahead because we fear what is going to happen in 2032. So we should be accepting and we should be liberal and we should be in a mode. We own the results are coming and we transform them with the wisdom of the senior experienced person like sir, and with the wisdom of researchers and universities, we transform them in midway as well. Thank you.
Thank you very much. I think that was a very thought-provoking, integrative framing of all of this. Just some numbers. Just the Narega, 65%, PM KSY, 3 schemes, Atal Bhujal Yojana, Jal Jeevan Mission, National Hydrology Project, and a little bit of the Matsya Yojana. Per year, 1,22,000 crores as an outlay. So we are looking at something like anything between 15 to 20 billion dollars a year, which is available. And you mentioned many more state schemes which really add to the kitty. So the problem is not the resources. as you're pointing out, problem is more how do we work together. Thank you very much. Last but not the least, and especially from a historical perspective, Yadavji, yeah, over to you.
First of all, my congratulations to all the presenters who was given really insight to the climate change and adaptation strategies. As rightly said by the chair, the first part was mainly sharing the experience and strategies to adapt to this climate change. And the second part was a bit scientific, where some studies has been conducted and some results has been shown regarding water resource management. Key points can be many, but we can summarize few. I was very much moved with the fact that more emphasis has been given over the last decade or so for revival of the local ponds, lakes, and farm lakes under different schemes, as you are saying, Government of India schemes or state government schemes, Manrega and other schemes. Probably this has to be taken further with a more thirst that such lakes and ponds and talabs and should be rejuvenated or renovated or revived. They were there, water bodies were there, existed, but now they have vanished somehow under this development of the schemes. So this revival of the lakes and ponds should be taken. One. Secondly, I am a meteorologist from IMD, cannot run away from the responsibility of giving correct type of forecast for correct type of weather. We had models for giving rain. Okay, I'm just giving an example. And the model starts forecasting for whether it will be light rain, or moderate, or heavy or severe rain. The same model is being used for forecasting from light to heavy rain. Now, when we are getting so much of cloudburst and flash floods events occurring in the country, we need to have specialized models for predicting this climate change, not change, but impact climate change. And cloudburst is one such event. We don't have the model. Of course, we are developing models which are high resolution and very location specific, but still we need to do more as a government organization to develop such models which can give accurate prediction of the cloudburst type of the things which are the outcome of the climate change. Third is the development of a seamless system of visualizing the current status of water level and its forecast. Meteorological forecast is one thing, but ultimately, as Arora sir has said, climate change means water scarcity. So we have to go to water. And therefore, we have to have some sort of hydro SOS. If I call it hydro SOS, means hydrological status as of now, whether the status is normal, below normal, above normal, with respect to the historical records, and what is likely to happen in the next 1 week, 2 weeks, 3 weeks. That time of hydro SOS has to be developed. IMD is, I'm happy to inform that IMD is working on developing a hydro SOS for India, not only India, for South Asia. In collaboration with WMO, and soon we will be, and of course, Central Water Commission, Ministry of Water Source, without them, it cannot be taken. And we hope that we will be able to develop a system, seamless system on GIS platform, to see all the water bodies, how much water available to us as of now, and whether it is good or bad or normal, below normal, and how it will change in the next 1 month or so, depending upon the weather forecast. Third, and the last, but not the last, I will say, the involvement of, I was happy that to see that NGOs are participating in water research. The startup company, my friend sitting there, he has started a startup on this. This is really encouraging. So therefore, the involvement of more and more such organizations, NGOs, community approach is required. So that for that we have to take up a serious effort that to involve our NGOs, such type of organizations, private organizations, public-private partnership, and community involvement in tackling the impact of water, this climate change. So with this, I conclude, sir. Thank you.
Very, very precious inputs from you. Maybe I'll just add 2 and then hand it over for sir, with your permission that we close after that. Okay. Thank you, sir. Thank you. Thank you for also agreeing to change the format given the time. So I really appreciate it to both of you. I think two things, integrative, you mentioned, and also the use of GIS as an integrative technology. Ministry of Rural Development, through its work and the Bhuvan portal, now has GIS layers for all of the 260,000 panchayats, as you heard from the Honorable Secretary today. All of this is available within, the problem is compartmentalization. It's available in Bhuvan, may not be accessible to others. But I think if you're building up a geospatial data layer, and if you could put this on top of the same layer, it'll advise the planning to be more dynamic. At the same time, it'll also help you not to have to do the other sector level works. So I think there's some ideas we can pick up on. The other idea which I found Secretary Sir mentioning is that if water is the problem because of climate, water is also the cure. So if we look at this whole idea of natural farming, where we're going into low input agriculture, which is a form of conservation agriculture or a permaculture, but not in blindness. It's actually looking at the food security. It is working to produce the same amount of food. And there are many experiences he mentioned of Andhra Pradesh. It's also happening in Himachal. It's happening in many states. It's being talked of. I think if we look at change in agriculture also with the agriculture department, then the use of water also changes. And then all the technologies can aid that shift as well. So I think this is another, I find that we are missing agriculture here. And that is the next one we should think of. So with those words and thanking you all, I just hand it over for the closing remarks to the organizers of the workshop. Thank you.
Thank you so much, everyone, all the presenters, our esteemed chair, co-chair, our panelists, everyone for indeed a great session and an insightful session. We quickly want to wrap it up, and as a token of appreciation and love from our end, we would like Mr. Krishna Tyagi to please come up on the stage to give the mementos to all our speakers and presenters. I request Mr. Tyagi to please present the memento to Shri Nagendra Nath Sinha, Shri M. Gopalakrishna, and Shri B.P. Yadav. So I request sir to please present the memo to Shri Nagendra Nath Sinha. He's not here? Okay. Shri M. Gopalakrishna. To Mr. B.P. Yadav. To Mr. Sunil Kumar Arora. Shri Yogesh Kumar. I would now like to request Mr. Krishna Tyagi to present the memento to Mr. Rajiv Ahel for moderating this entire session. Thank you so much everyone for being a part of this session. Now, one by one, I'll be inviting all the speakers to come up on the stage to receive their mementos, and I would request Mr. Krishna Tyagi to please stay on the stage. Thank you, sir. I request Mr. Anshul Agarwal, MIS in charge, to please come up on the stage. Okay, so can I invite Ms. Shilpa Nag on the stage? Thank you. Arvind Saxena has joined us virtually. Can I invite Ms. Srinivas Bilakanti to please come up on the stage? Dr. Arvind Kumar, Shri V.D. Loyana, Ms. Radha Priya, Dr. Renga Lakshmi R, Mr. Joshal K. Bansal, and Ms. Tanya Divedi. And I request everyone to please stay on the stage for a group picture. So we have a lunch break right now for 30 minutes, and again we'll meet you all for another session at 2:30. So I request everyone to please join us back after a quick lunch break. Also, if anyone is interested to go for the Agra trip, I request you to please register yourself at the registration desk. We also have some goodie bags and bags from the International Water Week, so I request everyone to please collect it from the registration desk. Thank you so much, everyone, for being a part of this amazing, knowledgeable, and insightful session. We hope to see you at 2:30. We'll just take a short lunch break and we'll be back again with another insightful session. Thank you so much.